just recorded that, but I did, and that's okay. Go live. All right, looks like we're live on view profile. Yeah, we're live there. We are live there, and we're live on Twitch. Hey, Wings Cancer is here on Twitch.
Hey, come and check out the stream with us.
All right, we're live everywhere.
We're live everywhere.
Address everyone.
Hey, YouTube, Twitch, the internets, everybody else, Facebook. We are here. We're going to be live streaming the NVIDIA event. We know they're introducing new hardware here. Everybody expects the RTX 2080. There have been rumors of an RTX 2080 Ti, as well as a 2060 and 2070. Rumors say this thing is supposed to be insanely fast. Word of advice, if you actually want the NVIDIA stream itself without any of the MST Theater, you may want to go to their stream directly. I'm sure it's on NVIDIA's webpage. We are here to also offer analysis, witty banter, and to play G-Bingo.
G-Bingo.
I want to play. I will drop a link in somewhere. We're going to be playing G-Bingo.
Give me the link.
This weekend. I'll give you the link. Where do I put it?
It's Slack.
I'll
Put
just give it to you.
Yeah, I'll put it in the chat. And there's Elena.
There's Elena.
Hi,
She's
Elena.
coming in.
Hi, everybody.
Coming in hot. Oop, that's the wrong damn
Oh,
one.
my food. Should I close the door?
Yeah, probably.
Yeah, because they're doing construction here.
Yeah.
I think they're.
Hello, everyone.
So yeah, so Adam will drop in the link. I hope to.
Yep.
Let's make sure that works to the correct place.
Oh, I got it. Yep.
All right.
Hey,
Let's.
Adam.
Yes.
Should I turn
We're live off, by the way.
I know.
Okay.
Should I turn on the monitor?
What's up?
I turn on the monitor?
Oh, I mean, yeah. I mean, all we're gonna see is just this anyway. So.
Oh, they can't see us?
I mean, they will see us.
Okay.
Yeah. Here's what it looks like. Although it's just the YouTube. We're not showing the overlay.
Not yet.
We're showing
Not-
Elena walking on now.
Yeah.
This is like it's like going back in time.
Oh, cool.
It's like the Omega
There we
13.
go. G-Bingo. Man, we got everybody here.
G-Bingo here. Got some G-Bingo
All right,
cards.
just to let everybody know, I have a meeting at 9:30, so I will have to skedaddle.
All right.
Well, let's see. I'm gonna 30 minutes. They could bust it out before that.
Very true. I might be able to be here just long enough to get the main scoop.
There you go.
Yeah. So G-Bingo, Adam will drop in.
Yeah, I did it.
You get an authentic no prize. Which means no prize.
I do
From
like
Marvel
my no
Comics.
prize. I don't have anything to clutter up my desk.
And so live in Germany, in Cologne, Germany. I think we're told we pronounced that incorrectly. They just let everybody into the theater. Looks like several hundred people.
Wait, who said that we're pronouncing it incorrectly?
I don't know. It could be like Cologne. I don't know. We don't know, right?
It's
I don't know. I'm not
Cologne.
from there.
And it's Köln auf Deutsch.
But maybe that's what they tell us. Like over there, it's probably like, yeah. I told them to pronounce it Cologne.
Cologne.
Whatever. Or yeah, who knows what. Anyway, at the theater, hundreds of people. It looks like, good Lord, it looks like probably 1,000 people in this theater. Pretty large. Looks like, hey, somebody just, back
Hey,
at you there,
Is somebody
dude.
trying to do a okay?
You know, I'm going to switch over to it. Let's see if we can spot Brad in the crowd.
Yeah, let's see if we can. Oh, yeah. So there we go. We're going to be this little box up
Yeah,
here.
well, why don't you mention that Brad is in the crowd?
He is somewhere.
Yeah. He went to Cologne, Germany.
Yes.
Are we
Brad is in
pronouncing it that
Cologne.
way?
He's in Cologne.
TMN.
That is the most awkward fist bump ever.
001 in YouTube says first price rumors are pretty crazy right now.
Really?
Yeah. Have you guys seen the rumors on the pricing?
Yeah, whatever. If you put any stock in any of the pricing rumors at this point, you got to be insane. The only people who know the price of that card is probably Jensen and maybe his secretary who created whatever the PowerPoint. That's just like, no way.
Oh, Jabaro Yak on YouTube says that the Micro Center had the RTX 2080 Ti on their website this morning. Did you guys see that?
No.
No. All right.
But, how
don't
do you know
follow
that's
Microsoft.
real?
Yeah.
There have been, at this point, I don't know what to believe. Everybody was absolutely sure it was 1180 up until, 2 weeks ago?
I'm gonna unmute the feed and just put it down real low because
I
they're
can do some PUBG.
Right. So they got a couple...
they're doing their talking. We'll keep it.
Oh, hey, Adam. I don't know if you can
Yes.
fix this, but it looks like there's a typo in the Twitch headline. Or the name of the Twitch screen.
Whoops.
Stream. Excuse
Watch
me.
the NVIDIA announcement. Announcement.
Copy editors. They're no fun.
Announcement.
Bushes and in the forested region.
It's in my blood at this point.
Announcement.
Let everybody else do it.
Yeah,
Wait.
that's my strategy.
Announce.
So
Just flip the N and the C, I believe.
And ANNOUNCE, announcement. I just have to spell it out.
Boy, so what were the price leaks? Where are you getting this?
I don't know. Is people on the YouTube chat telling us,
I should log into YouTube chat.
and I just changed the typo, so I can't change it on Periscope, so too bad.
Brad is reporting Wi-Fi there is sketchy.
Yeah.
that
But we
sounds
got
about
some
right.
people asking where's Brad, and we'll remind them that he is there.
He's sitting
there
somewhere
in purpose,
in the audience, although this is the...
on location, I should say.
Ahí está.
Mr. Zombified is saying RTX is on Newegg right now.
Is it really?
And Chris Robertson saying
Going on
the price that he saw, but I don't know what that symbol is. It's 750,000
yen
with like
I
a
think.
Y, with like a 2 lines through it. I don't know what that is. Does anyone know what that is?
I think it's yen. Who knows? So basically you're saying, well, assuming TN M001 did the translate, yeah, funny.
Total area.
$1,200.
And also,
I don't know about that.
1,200.
it is wall-to-wall.
Ruber2 says the 2080 is going to be 666 and the 2070 is going to be 555. Yeah, right.
You know what? If you guys are tuned in with
And yes, that was in yen.
our YouTube channel GeForce, you're going to get to see
And E. Lopez 580 says these NVIDIA pre-show hosts are very cringy to watch. Yes.
Well, it's all right.
I
Just a
think
little bit.
Could be worse.
I like
Could be us.
It's hard.
it's a hard job,
It is a hard
but
job.
I do feel like they're not used to presenting. That's what it feels like to me.
Yeah.
It is a hard job,
You
though.
got to maintain excitement. You have nothing. You can't give away any secrets.
Yeah.
We should take a
It's very much like all of the news channels, basically 90% of the time. Well, let me ask you something. Do you think this pricing is any good? We don't know the price, Chet. We're just guessing.
Cyberclue says, shall we eat paper on our price predictions at the end of the year? Do we want to put prices down?
I have so much I already have to eat, you all.
They're saying $875 for the 2080 and $1125 for the 2080 Ti.
God, that, you'd almost think at that pricing they could continue to carry 10 series cards.
They probably will.
Which is possible because they have no competition.
Oh, well, and remember when they were talking about, we've got millions of them in stock, I bet they're going to have it around for a while.
Yeah.
Also, that might help with mining, right? Because then the miners have access to the old cards. Or the new
Mining's
cards,
dead already.
Yeah, but still, it still takes out a chunk, I bet.
Yeah.
Too bad we can't see Brad on this shaky cam.
He's in there somewhere, folks.
Now they're just playing some music. This is probably copyrighted, so we're going to get busted. Just kidding.
No, believe me, there is no copyright
Wow,
on this
that is
music.
very European.
This is not even real music. It's machine language created music.
Gordon, where's your glow sticks?
This is just like random. Oh my god, I hate the
and now
event music.
NVIDIA's.
Oh, are we losing the stream?
Yeah,
We are losing the stream.
Oh, there we go. We're back. We're back.
I'm using NVIDIA's official Twitch stream to stream this. Also, people are wondering where AMD is right now and what they're up to.
I can tell you what they're doing. They're watching the stream right now because as a way you want to know what your competitors are doing, you want to know what they're doing immediately. And they are watching the stream.
Go and talk to other more important people, but I'm still here.
Oh, he's still
You're
here. Good.
Great news is
I don't know who he is. Somebody mentioned that the lady was from
probably gonna blow your
the
mind a
Tech
little
Thing
bit, and you're gonna have
podcast.
lots of questions, and you
I know he's got Einstein on his shirt.
with which
Oh, yeah,
ask
I
those
see it.
questions. Go ahead, type
I like
them
it.
out. We're going to be talking to devs of some big games and some small games.
Very gaming focus, obviously,
We're gonna
since
be
it's
showing off
at
some really cool tech.
Gamescom.
If you
Gamescom
know anything about
in
that,
Cologne.
pass that along. Type it out. We'll take it down, and I will ask them. All right. So while
yeah,
we're waiting
hopefully
for everything to
Twitch
begin, I just
will
want to remind you we are here
hold
at
tight.
Gamescom, the pre-show that NVIDIA's got set up. We
All right,
do
I'm
this
gonna.
every
Sorry,
year. The
I'm
event is
neglecting
always
chat.
big, right?
Oh,
Hello,
right, right.
everybody on
Show some
Twitch.
cool tech. And
Man,
I
we
gotta
got
say,
everybody here.
I've
Dragon
never seen
Kurt's
one
here.
this big before.
We're missing
We don't know
Bastel.
what's going on. There seems to
I
be
just
some
wanted to
sort
say
of
his name
wave
to show
building.
that
I'll just put the link in again.
Avatar,
I'm going to put in the...
Yeah.
flying around.
Oh, I can't wait.
And
I can't do
W
it.
Kuma.
I'm not approved.
Oh,
links
are
from
you on
me.
YouTube?
Yeah, I'm on YouTube, so no links for me.
Just
I'm
say something and I'll make you an admin.
quite
No,
sure
that's
why.
better not to.
All we really know,
Okay.
looking at
Don't
what
make you
NVIDIA's
an
done
admin.
so far
All right.
this
You can
year
just drop it in
and
again.
the past, is
Uh,
that they've really got something probably up their sleeves that you're going to want to see. In
I
fact,
think
if you wanna
this
get hyped
person
again,
must know.
I'm going to go ahead and show you.
Oh, you think they know?
I'm
Well,
coming, Sam and Dave,
you
all
think
the
that
gamers
this
get
guy
to
knows how
play
much it's gonna be?
before the game. Check
Hey.
it out.
Oh wait, we're gonna get game cuts now.
Oh.
Nice.
What is this?
Something's
I'm
happening.
gonna turn it
Oh
up.
wait, here we go. So if you're tuning in late to the stream, folks, we are looking at a NVIDIA's live stream unbox.
Oh,
Oh no.
Oh, this is just like, hey, NVIDIA's for gamers and builders
Yeah, I
and
didn't know
people
that.
just like you. Look at all
Those are
these
some really
cool
nice
things.
systems.
Yeah.
Okay, I gotta ask. Do you wear a hat when you game?
No,
Do I wear a hat? No.
It's already warm enough.
Also, the only women they showed was playing on a laptop.
But do you like the hat? I just don't think I'd ever. I take my hat off when I'm playing games.
You wear hats?
No, I don't. Yeah, I do. Look, see that? They have that. Look, that's two gamers wearing hats when they game.
I don't know. We should put that
See,
one to
clog me.
Hey everybody, I am back again.
hashtag be
here
there for the
in
game. All right.
Keynote Hall,
I'm gonna
which is
turn these
amazing.
people down again.
Packed in here. I am joined
All right, so we're guessing. I guess I understand it's on Newegg now. People are saying what,
I looked.
$1,100?
I didn't
no.
see it.
Yeah, I suspect they got a call over at Newegg.
And William Flanagan he's excited. It's their first live stream. Hello, welcome, William. Yeah, cool. Everyone's excited. Everyone's missing Brad, and I
Brad
wish
is
Brad can join us
seeing
too.
someone in the audience.
But he is literally in the audience, and the Wi-Fi is not good enough to try to Skype him in. So
Hey, so
don't even want to try that.
Daddy Steps, I got to say, is saying NVIDIA is for everyone who has disposable income.
What do you think
And
about
that is not exactly true. It is for everybody who has a disposable income, and it's actually very affordable because 1050. Well, mining craze behind us now. Hopefully, prices will get back to normal. And, 1050 is a decent card for gaming. For and the what was the one that came out with the DDR4? That definitely was not a great card, but I think
You talking about the
that's unfair.
1050 Ti?
Yeah.
Oh yeah, the nerfed one.
Yeah, you got to remember everything NVIDIA pricing has just been wacky because of mining. Just like look at AMD, it's still crazy. Yeah. Yeah, 1050. See, if these rumors about a 10 or 2080 Ti and 2080 are right, then 10 series could almost live alongside 11 series or 1020 series. Don't you think?
Sorry, say it again.
We're reading the chat.
You were trying
Yeah,
to read that.
Trying to read the chat.
Yeah, I'm trying to do 20 things at once. What was the question? Please repeat that question in the form of a question.
So what I'm wondering is if the prices that are saying, because obviously people are saying, hey, several stores did the accident of putting them on sale even though they're not on sale, and then the prices were what, $1,100 I think is for the 2080 Ti version or something.
I'm gonna go ahead and throw it back.
So that sort of implies everything is a couple $100 down from each of those. Do you think it's a chance we're going to see 10 series live alongside 20 for a while?
Yes.
Like, so, I mean,
Yeah.
a 2080 for $450 now, give it a couple months if it's down at $300. 2080 for 300. You're like, as
Well, not
Brad has
a
already
2080.
said. Yeah, I mean, a 2080, but a 1080 for 300 for 1060 pricing
I don't think
or
it'd go that
1070
low.
pricing.
I don't think it'd go that low.
I think here's the better question. Will the 10 series, assuming they keep it around, stay at street price? Or do you think they, stay at MSRP? Or do you think they'll drop the MSRP to say, hey, you know what, the 10 series is going to be around, but it's for the more budget-minded people? Because street could drop,
depends.
obviously, but do you think they actually say, hey, no, we're going to drop the MSRP?
I think it's going to depend on what the prices are for the 20 series cards. So if those are 100 or even more over MSRP for the last gen, then I think it's possible they might lower the MSRP for the previous gen just a little bit to, separate them. But I don't think it's going to be that big of a deal.
Yeah, we'll see.
Yeah, I don't know. I mean, I can imagine that 2080. I mean, who knows? It's hard to say, right? Because people sort of assume it'll be hard to get initially. But they've been probably making these things for months, and they could literally have that
stockpile of
container ship of graphics cards going around the world like Santa Claus. So it could be they just want to get rid of the old 10 series for the most part that would compete with the 20 series and push people to buy higher end. Or they could say, if yields are not as great as they are, because it is apparently a pretty big die, maybe they're going to say, hey, we're going to try to keep demand for the new stuff low by keeping prices high, and we can still sell them 10 series. Because the worst, NVIDIA does, what they don't want is people to go, I'm going to go get a Vega. Right? Or an
Well,
RX card.
If
That's
they, can they find them still?
if you can find it. And the prices, there's still, prices are not great on Radeons. So
I think they're going to keep it around. But I mean, they have so many segments of the 10 series now for like, you've got the TIs, you got the weird versions with the different onboard memory. Like I think they list it. Mark says RTX 2080 Titan accidentally listed for 4,000
see,
euro.
This is probably just like NVIDIA's like, go ahead, just make up crazy ass stuff and put it in your storefront.
Just do it.
But here's a really good question. TNM001 said, how fast do you guys think RT features will be adopted, making an RT 1070 like necessary for enthusiasts?
Not fast at all.
Yeah, generally, game developers go generally pretty slowly.
I mean, if you got the joke is DX12, right? I mean, we're still waiting for widespread adoption on that. So, I mean, if everyone's saying that ray tracing stuff is the future, it's not gonna happen like that,
But there will be some key titles. I mean, I'm absolutely
course.
certain that Jensen will be on stage. They'll have
of course
2 to 3 to 4 developers coming out saying how they just are in love with real-time ray tracing, and they're going to add it to their game.
Yeah.
Does that mean you got to dump
sure.
your 1080 and buy 2080 today? No, probably not.
Yeah, I doubt you're gonna dump it.
Yeah,
But also, I feel like even the implementation is going to be so minimal because the amount of market share, the amount of work it probably takes to put that in your game,
Sure.
versus the amount of market share that's actually going to use it. I mean,
right. But here's the thing though, because everybody's like, why is it taking so long? What's taking so long? It's like, it's hard work. You're doing a game, you have fixed resources, and you're going to do this one other thing. Hey, we're NVIDIA. We love these cool particle effects, these new ray tracing features. Why don't you just use our GameWorks module, right? You do that, the developers go like, "Oh wow, this is great. You're doing all this hard work. We don't have to devote our resources to do this. We'll use GameWorks. Not a problem." Internet freaks out, says, "Oh my God, GameWorks, it's just kind of like, what do you do, right?" And the developer, of course, looks like, oh my God, we're on the take because NVIDIA is trying to make our game only run well on GeForce. But if it's going to take them 24 to 36 months to implement some new feature, and you have it now immediately by using GameWorks, what would you rather have? So I mean, there's just some things. Whatever you think about GameWorks,
look, Brad's in the chat.
Oh, Brad's in the chat too.
Hey.
There he is.
Brad, how do you pronounce Cologne?
It's cologne, like the
I don't think
actual
you can
fragrance.
pronounce it over
I think
text.
it's Cologne.
Maybe you
Hey, look at that.
Yeah,
It's
Cologne. No,
No,
Cologne
E.
is what I'm going to say.
Are you trying to pronounce it like baloney?
Baloney, Cologne.
Here's another good
Oh,
point.
hey, you know what? Yeah, are you
What?
thinking of Ruru2's comment? It made me just think of ray tracing is not going to be heavily adopted until the next gen of consoles adopt it, Gordon.
I disagree because we are sort of back to what it was in the 1990s, 2000s, and the premier platform for your game is the PC. People see how some games, the tier 1 games have been on PC now. They are going to be implementing it. I don't think they're going to do this. We're going to wait for lousy consoles for this. I don't think that's. I don't think that's going to affect it. Sure, for certainly some smaller developers, but Epic's not going to sit around like, oh, let's wait for it in consoles. No, I mean that could be like what 2025 by the time you get these features.
Epic still makes games,
but I'm just saying their engines.
True. Also, Brad's saying Colch.
Colgate.
Oh. Did we lose?
Oh, we just lost audio.
Oh, there it is.
Oh, there you go.
They did. It was them. It wasn't me.
Oh, so they.
Yeah.
Thank you so much for joining us.
I'm still not seeing Brad in the back. If anyone sees Brad in the background, you should chime up and we'll take a drink.
Gamescom tomorrow. Super excited for that.
And I disagree. I
Oh,
can't
Brad
find
has
it.
a video pause. That's funny.
Oh, is it?
Just so Brad
He's
has
just
a
in the
video
chat
pause
only.
just so he can chat. That's funny.
So CyberClue says, I think NVIDIA is promoting ray tracing so much because they can't justify the impending gargantuan jump in price, along with a moderate increase in performance. I think that's a great spin if you're anti-NVIDIA. I do think.
Also, we don't know if it's moderate.
Right. I mean, but no. I mean, it's a possibility that what we could
Where's
see.
Brad?
It's possible that in existing legacy titles, which is everything today, the performance increase might be nothing to sneeze at. Because do you really need more than 200 frames a second at 4K? Right. Whoever knows what it is. But I think they are pushing ray tracing because that's where the future is.
They've been pushing it for a long time, though.
Yeah.
If you
I found
go
the
back
Newegg
even back
page.
to like what Maxwell, they were talking about it then. It's kind of like I think their holy grail.
Right, and it has
It is
been
the holy grail.
But I got to say, that's kind of the way I've seen this. We've all seen it. If you follow it enough, that's the way the cycle works. You don't try to make performance on things that are irrelevant go faster. You try to make performance on things that you want to play in 24 months go faster. So it's a balance.
The side note, Archlord on Twitch, I just put it in Slack. They found the Newegg listing.
Oh, what is it?
Oh, great.
It's like a promotional page. It's got Asus, EVGA, Gigabyte, MSI, PNY, Zotac.
Oh no! Somebody says the show isn't expected to start until 10 a.m.
What?
Pacific.
Really?
Oh.
If that's actually true, I can come back after my
I
meeting.
know, right?
Well, I got to work on a story so they could watch the stream and watch us type.
Yeah.
Yeah,
We can
right?
come back and just hang out.
Jeez.
See, I don't see a price though when I click on the link in Newegg.
Oh, Brad says that the music might be indicating something's changing there.
It's not the actual listings when you click through. I think this is just their promotional page getting ready for it. But do you think that? I mean, that looks like the reference card with the two fans.
Where's the link?
I just put it in Slack.
Oh, okay.
That's interesting. And then they've got.
Yeah, I do think like people saying AMD did ray tracing first. It comes down to who has the right parts at the right time. Often in this industry, it's a lot of people think being first matters. AMD, ATI, you got to give them credit for a lot of things. They were first, and it bit them right in the butt. HBM bit them right in the butt. Right? They are always pushing memory technology to the bleeding edge, and it doesn't always benefit AMD. It doesn't always benefit end users, their customers, gamers, because you can't get the parts. HBM memory was impossible to get. So you give it to them for pushing the envelope there, but if you want to be the thing that matters to more people, you also have to time it right.
Yeah.
I don't know if RTX is going
Oh, interesting. This at least tells us who the
partners are.
the partners are.
And there's no Founders Editions?
Well, there's a
Scroll
picture
through.
of what looks like to be a Founders Edition. I think I saw an article from WCCF Tech showing the Founders Edition with that dual fan design.
Are they?
Oh, yeah.
Are they starting?
Oh, I
Looks
don't know.
like it.
Do we see Brad?
If they switch back, maybe
But
they
they
had
muted
technical
it.
difficulties. But they're muting the stream right now. So they
Yeah.
might be having technical difficulties.
Who
Looks
knows?
like
Whoa! Look at that galley
a
up
solid
above.
1,000 people in there.
I got to tell you,
Maybe a couple.
There's like a second floor.
knowing how live streams run, all the people in the background are probably just running around like chickens with their head cut off. Just,
Yeah.
This just in, there will be an RTX 1030 with DDR3 memory.
now you just
Someone found
Now you
something in the
just
back,
troll.
What I always
back of the
like is
warehouse.
you
They had to
hear
clear it out.
when they do this thing on TV. When they're yeah, I know. Well, it's just the whole because Elopes 580 was talking about DDR4 1030.
it was the 1030.
Those are horrible.
we messed it up early as well.
No. Did we? Yeah.
Yeah, we said I can't remember what we said, 1050 or something.
I can't. No. Well, 1050 is a good part. 1030 was that DDR4 one, which was bad.
Yeah. And Fragalot's asking, is this the same stage they used when they announced the 1080?
Oh, wait. The stream just went black on the screen.
Oh no.
Brad, if you're there,
Wait.
take a lighter and wave it, then we can know where you.
Oh,
here we go.
Incorporate this technology into my art and have the two mixed together.
Huh, CGI porn.
Oh.
It's kind of fun.
I'm guessing it's Turing. Alan Turing, maybe?
21 minutes late.
We were making a lot of decisions where we thought things were going to be because we didn't have the compute power to support at the time what we wanted to do.
Oh.
So at lunch one day, a Bell
Oh no.
asked,
Come on.
what would it take to ray trace this scene in real time? And I said, well, we need a 512 by 512 array of Cray supercomputers, each with a red, green, and blue light bulb on top. And we'll put it in the desert and fly over it at 10,000 feet and take pictures of it.
Nice. What an amazing movie. They literally traced it by hand. Oh yeah,
Wrath of Khan.
Wrath of Khan.
Interesting.
Classic.
It's all cinematic movie scenes.
Yeah. People are going to be editing the next Star Trek movie on
real time in the
2080.
game.
Sort of
These are all
10 or 12
cinematic.
months of hell getting these shots.
The
done,
book
and it
was better.
because the render
No,
times
but
are
it's
so
significant, I
horrendously
think,
long.
because
Oh, Terminator 2. Yes.
my
Jurassic
son
Park?
was like, "What about all that CGI in this movie in Star Wars?" There was no CGI, kid.
Well, the blasters were literally.
Oh my goodness.
Oh, nice.
This is a throwback.
Quake.
Ah, yes.
Come get some.
The history is really nice on this. My memories. Oh, the brass demo.
I like seeing those old demos. All right, we got to get ready for. Do you have some G bingo, Elena?
I'm going to have to leave in like 4 minutes.
Okay.
You could probably come back at 10.
I probably can.
See all those classic NVIDIA demos.
Battlefield. World of Warcraft. Oh. The music's like, 8080. I'm sorry, 8800. Crisis. Yeah. This is a pretty good demo.
Oh man, that lunar landing one was so good, that demo.
The Division. Wait, what? Destiny 2 didn't push any boundaries.
We've come a long way, folks.
Cyberclue says Tron fights for the users.
Mm-hmm.
Ladies and gentlemen, please welcome NVIDIA founder and CEO, Jensen Huang.
Wait, is Jensen on our G bingo?
No.
And Cyberclue also says what? No clip of the Bayonetta? I'm disappointed too.
Yeah, obviously, don't pay attention to us.
All right. I gotta study the words too.
Guten Tag, Gamescom.
You should have had Guten Tag on there.
Welcome. First of all, great job, guys. We're gonna kill it. Don't panic. Everything's gonna be fine. There's so much technology in this room right now. It's barely under control. Okay, so you guys are gonna have a great show.
Ruchi says he got a new jacket.
The launch of the GeForce
You got GeForce on?
GTX 1180.
GTX.
He's messing with us. See?
The applause is
Everybody's
just
like,
Is this his comedy sketch? Is he's like gonna go up there and
I
do a
have
little
never
comedy sketch?
seen anything that leaked this much. The good news is you're going to be surprised. We didn't do it on purpose, but everything on the web, every spec
too loud for you guys?
is wrong.
Yeah, right.
You're going to be surprised.
He's lying.
It's going to be a great show.
Disinformation.
This is a historic moment. This is a historic moment for computer graphics. For as long as there has been computer graphics, it has been the dream of computer scientists to generate with computers photorealistic images. When you look at this, what we consider the holy grail of computer graphics, you see some effects that today are simply impossible to create. First of all, light is coming in from the window. It's bouncing all over this room. The vast majority of this room is being illuminated indirectly.
Illumination.
Whenever light touches a material, strikes
Ruchi's
a
watching
material,
the
that
AMD
material
stock.
is rendered
Oh no,
and
NVIDIA stock.
simulated physically. The material is metallic or dielectric, is either smooth or rough. The roughness can come from microsurface structures that bounces light. absorbs light, diffuses
No.
light in a very
Twitch.
different way.
Here we go. We're back.
Maybe it's orientation dependent, maybe it's not. Some of it is glossy, some of it is matte, and as a result, this entire room looks alive. As light is bouncing around this entire room, it doesn't strike every surface the same way. Some of it is occluded from light. We call it ambient occlusion. You also see that there's a desk lamp, and it's shining through the glass, and because the glass has curvature and shape, light refracts around it and accumulates in a way that we call caustics.
It's painful.
That little bright.
175,000 people watching.
Wow.
I bet the people at Twitch are...
on the table is particularly attractive.
David, that's not very nice. I'm going to have to hide that comment. Keep doing that, and I'm going to ban you.
Oh, dang it.
Come on.
I have no idea what
This is painful.
Shadow of phasma coming from all different directions. It's called umbra.
I think he's just given a physics lesson.
Umbra is where the shadow is completely occluded, and penumbra is where it's partially occluded, and so you see the sense of soft shadows.
Also, David, if you came to
She's
here
reflected
to
in the
see
mirror,
him talk, then
even
you came
the
to the
parts
wrong
that
place.
you don't see.
So you should just go straight to
You know
the,
how mirrors work. You could see behind things.
The stream itself.
Oftentimes in video games, we can't do that. The little bit of shadow behind that painting, ambient occlusion, or as light travels through those gummy bears, bounces around inside the gelatin, and then reflects and refracts it back out, called subsurface scattering.
Hey, I got GTX.
All of those little tiny effects
GTX and
are really,
NVIDIA.
really hard to do. And the good news is, in 1979, a computer scientist named Turner Whitted, now a researcher at NVIDIA, described an algorithm that was both powerful and elegant. He called it multi-bounce recursive ray tracing. By starting from your eye instead of from a light source where light is emitted, because the vast majority of the light doesn't reach your eyes, so there's no reason to trace them. He traced light backwards, inverse ray tracing, through the eye, through the pixel, through every single pixel on the screen. The ray would seek out, would be sent forward, and if it were to strike a triangle, it would then send off a shadow ray to decide whether it's in shadow. That shadow ray would go towards
just give us the price
light
and performance
sources.
numbers.
If there was something else in the way, if it strikes another triangle, it would determine that it was in shadow.
I didn't watch the SIGGRAPH talk.
And if it doesn't, then it would accumulate the color and the intensity of that light would then be used to shade that surface. If that beam of light, if that ray going through another pixel,
SS is wondering, why does this guy always wear a leather biker jacket?
It would generate shadow rays to see if it's in shadow. And it would also generate a reflected wave, a reflected ray, a reflection ray.
Jensen?
That reflection ray would be basically the same incident angle relative to the normal of that surface where it struck. And then it would go off.
Oh, no.
And decide whether it strikes another triangle. And if it were to strike another triangle, it would create shadow rays. It would determine whether that particular surface was in shadow or reflection rays and such. And if it was to hit into a surface that is translucent, then it would generate refraction rays based upon Snell's law. And that this algorithm, this basic algorithm, would recursively run. And eventually, he would generate this beautiful
Gordon,
image.
you see what Brad just said in the chat?
He generated this image. And it took 1.5 hours on a $1 million VAX computer. Basically, he was generating 60 pixels per second. Instead of 60 frames per second, he was generating 60 pixels per second. And so the question then is, how long would it take for us from that time for us to be able to realize this incredibly beautiful picture that I just showed you a second ago? Well, if you look at our technology curve, has been nothing short of extraordinary. And ladies and gentlemen, you have so much to do with it. Because of the extraordinary demand of video games and the scale and the size and the vastness of this entire industry, it has propelled.
Man, this David guy
one of the
really
most
doesn't like me.
Fast advancing
I'm taking
technology
it,
in the history of
very
computer
personally.
science. If you look at this curve, Moore's law has been the foundational thought, the foundational idea of computer science for 35 years. And yet during this entire time, since our beginning, we have been moving at 10 times Moore's law. If you go back to when Moore's law was following historical levels of increasing performance 10 times every 5 years, 10 times every 5 years, or 100 times every 10 years. Our GPU technology was advancing
Well, thanks to you for the
at
support,
1,000
Cyberclue
times every 10 years. 1,000 times every 10 years. And so the question is, and by the way, these are some of my favorite GPUs. Look at GeForce 256, the world's first GeForce. How many of you had GeForce 256?
Raise your hand, Gordon.
Incredible, thank you.
But the interesting thing is that curve, that CPU curve.
Look how
GPU
cute
curve.
GeForce 256 is.
Not new. That's just
at the time, so you know,
bad
at the
news for
time,
Intel.
it was the single largest chip ever built. It was bigger than a CPU. And people were shocked that we built something that big, and they were even more shocked that we could sell something that big. But anyways, GeForce 256. GeForce 3 was the world's first programmable shader. GeForce GTX 8800 was the first CUDA GPU. The most important GPU we had built up to that time. And then, of course, the most powerful GPU in the world today, the GTX 1080.
What, not
Well,
the
if you
TI?
were to plot out this trend and you were to think about how many rays it would take, you had billions of rays we had to send into that room, even though we're not simulating most of the rays, only the ones that are coming into our eyes. We're sending in billions of rays into that room. We've got diffuse rays that we have to do. We have reflection rays, refraction rays, and it's bouncing all over the world, all over the scene. And you have hundreds of polygons, hundreds of millions of polygons. The amount of computation necessary is easily in the several petaflops. Well, several petaflops, we're already at the teraflops today. So it would take approximately 10 more years at our current rate of progress to go from teraflops to petaflops. Well, we didn't want to wait that long. We didn't want to wait that long. And as you know, architecture is the single greatest lever in computer graphics. It is the single greatest lever of GPUs. So what are the interesting new ideas we could create that allows us to achieve effectively 1,000 times more performance 10 years earlier? And so we invented the NVIDIA RTX. The NVIDIA RTX is a platform consisting of architecture and software and SDKs and libraries that allows us to combine different types of rendering technology into one unified and cohesive platform. Of course, it should always take advantage of rasterization. Rasterization is so incredibly powerful and so incredibly efficient, but we also need to include ray tracing. However, just ray tracing at brute force level simply won't get us there. It simply won't get us there. In fact, I'll show you something later that's just really amazing.
Well, you didn't put
it
ray
simply
tracing
won't
in
get
there?
us there unless we use this technology we discovered
just
about
don't have it
6,
in your
7 years
bingo
ago
card.
called deep learning or artificial intelligence. We can finally create images along with ray tracing that allows us to achieve the levels that we otherwise can't imagine. Now, we leverage two fundamental rendering technologies.
Oh, he said
You know very well rasterization, which is the way that we do things today. We start with the 3D world. And we take the 3D world information, the vertices, the triangles, and we project 3D world vertices into a 2D world pixel plane, into our screen space. That projection leaves the silhouette of a triangle, and we have to decide and test which one of the pixels are within that triangle. One of the most beautiful things about rasterization is that you could parallelize an enormous amount of calculation. And nothing is more beautiful than being able to do things in parallel. That's one of the reasons why the GPU is so incredibly powerful at parallel processing. It started with the idea of doing things in parallel. It also has the ability to do things incredibly high resolution, because high resolution is just more things in parallel. And so rasterization was incredibly powerful. One of its limitations, however, is that every single time you want to light the world,
Cyberclue's funny.
you have to project light from that light. And if you want 2 or 3 lights, that's fine. If you have an area light, that's effectively infinite number of lights. And if everything in the room were to reflect light, and everything in the room became a lighting surface, otherwise known as global illumination, in the world of global illumination, all of a sudden the number of lights that you would have to cast inside that scene
Slim 420
is
says the more he
insane,
says incredible, the
and
more it's going to
therefore
cost.
undoable. Well, this
And
is
yes, we're playing bingo.
where ray
Let me
tracing
drop the link.
is particularly effective.
to
Because ray
bingo.
tracing, using Turner-Whittett's approach, simply traces the number of pixels that comes into your eyes, the number of rays that ultimately reach your eyes. The vast majority of the rays inside this room, the vast majority of rays in the world simply never are reaching our eyes. And so we immediately reject them. We immediately don't have to do them. And we start from ray tracing our eyes. Ray tracing, whereas rasterization is taking 3D world data, projecting it in 2D, ray tracing is sending out a ray of light, intersecting the pixel at the screen space, and enters into the world looking for a triangle that it would intersect. The two basic approaches both has its strengths and weaknesses. In the case of ray tracing, in order to ray trace this entire room, the number of rays, the trillions of rays, the hundreds of millions of polygons, the amount of testing that you have to do just to figure out which ray intersected which polygon is just extraordinary. You simply can't do it. Well, we put this platform together, and we worked with Microsoft to create the DirectX ray tracing, otherwise known as DXR, the Microsoft DXR. And then we worked with Epic to integrate RTX, DXR, into the Unreal Engine, the UE4 engine. And we found somebody with extraordinary art assets, Industrial Light and Magic, and together we created the
Star
world's
Wars.
first real-time ray tracing demonstration. It had never been done before. And we announced it this year at GDC, and I think it's worthwhile to take a look at it, and I want to show you something special about it in just a second.
It's a pretty good demo.
So this is
It's an amazing demo.
our demonstration.
Grant Murray says, but can it run Crysis?
You can run Crysis on Intel integrated graphics now. People don't realize that.
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector. If you ask me, who's ever in charge of this place should be transferred to Hoth. What? What?
Do you like the elevator music, Gordon?
Yeah.
You think she heard us? Yeah, I think
Star
she
Wars
heard us.
nerds. Why aren't they wearing snowtrooper armor?
Incredible, right? Absolutely incredible.
Oh yeah, that's the Volta rig that we saw at
And so,
E3
so
as
what,
well.
what you saw was physically based materials. It was sitting in an elevator shaft where there were area lights. And those area lights were moving as the elevator was moving. And therefore, as the area lights would illuminate the surfaces and the shadows would be soft. The shadows would be soft. Using area lights, it's incredibly difficult to render shadows. And notice the inner reflection. There's reflection off of Phasma. There's inner reflection of Phasma on her gun. And there's reflection of her gun on her chest. And if you look at the stormtroopers, the illumination and reflections are all completely in real time. Doing this is simply impractical today. The way that you would do it, of course, is that you would fake a whole bunch of lights that would slow down performance. It still won't look right, and all the shadows will look bandy. Second, you would create all kinds of what is called reflection probes made out of cube maps. But unfortunately, they're all moving. So every single scene, you're going to have to create a whole bunch more reflection probes, a whole bunch more cube maps, basically starting from the point where you would like to have to see reflection and rendering out from that point every single direction, turning into a cube reflection map. Those tricks simply are now practical with a scene of this level of fidelity. Well, it took 4 Tesla V100s, the same GPUs that are powering 5 of the world's top 7 supercomputers today.
Yeah.
It takes 4 of them in a $68,000 deep learning supercomputer that we make called the DGX. This is what researchers use to create their deep learning AI models. And so $68,000 to finally render running the RTX platform, real-time ray tracing at about 20 some odd frames per second. Well, when we announced it, people got so excited about it. They said, how do we buy that DGX? We could use it as a game console.
Oh, you got TGX on here. Nice.
And the requests just kept coming in. How do we turn DGX into a game console? The price point is slightly out of reach for most gamers.
For a game console?
And so today, I would like to make my first announcement.
Here we go.
Starting immediately, DGX.
All right.
Funny. Wait.
How many 3,000 easy payments?
3,000 easy payments of 1995. 3,000 easy payments. We'll throw in the first game for free.
What game?
So call now.
Crisis?
The telephone number is right below you.
Hey, it was a pretty sexy box.
1-889-789-2080. And good luck with that.
Are you calling right now? Put it up to the mic.
It's beautiful, isn't it? That's just
What is it?
completely liquid cooled.
There's no 889.
It is silent. Doesn't make a
it's
peep,
a lie.
And it
That
does
would be funny if it was
real-time
Pete Jensen
for the very
saying,
first time for
like,
$68,000.
hey, thanks for
Can
calling.
they
Turns out
do
what
this
we're looking
in
at
the
just
next
now
generation car?
was not running on that. It was running on this little thing. This little bad guy. This is called Turing.
Turing.
We've been working on Turing now for almost 10 years. Trying, failing, all these different algorithms, trying, failing, and finally, Turing. The most advanced GPU we've ever done, 10 years in the making, the greatest leap since we created CUDA, and computer graphics will never be the same again. Inside Turing is 18.9 billion transistors. This GPU, this chip, is the second largest chip the world has ever made. The only other larger chip is called the V100, which powers supercomputers all over the world. It has 3 brand new processors. The SM is completely brand new, has the ability to do independent floating point and integer operations. And the reason for that is sometimes you're shading for color, sometimes you're using integer operations to calculate addresses so that you could run your shader program to do things like subsurface scattering. And as more and more special effects are to happen, the SM's address calculation part of the logic becomes much more complex. 14 teraflops and 14 integer operations per second. I like to shorten it just to 14 tips. So 14 teraflops and 14 tips
to get your PC
It also
running
has the ability
faster.
to do this thing I won't talk much about today, but we're going to write plenty about it, variable rate shading, so that we could do things like
Please don't.
like foveated rendering, focusing all of the horsepower of the GPU where your eyes are focused instead of wasting it evenly across the entire space. If you're moving, we might be able to adapt the place where we focus your shading horsepower. If the resolution or the content detail is different across the entire scene, as most scenes are, we could focus our horsepower where there's the greatest amount of fidelity. As a result, you're effectively getting a several X boost in your shading performance. The second is a processor we call the RT core. RT stands for ray tracing core. It's 10 gigaраys per second. I love saying that, 10 gigaраys per second. A 1080 Ti, the fastest GPU in the world today,
Wait, he said 1080.
1080
earlier.
Ti does 1.21
gigawatts.
You guys got, no? Nobody ever saw that
That is
show?
Back to the Future. 1.21
gigaarrays per second. Okay, and so we do 10 gigaarrays per second, which is 10 times a 1080 Ti. It does ray. I'll explain that in just a second. A BVH traversal, tree traversal, and it does ray triangle intersection testing. And then we have a new processor called Tensor Core, which runs AI processing like crazy. 110 floating point teraflops. Or, because it has multiple precisions, depending on the type of networks you're running, you might be able to use lower precision or mixed precision. As a result, 440 TOPS.
Can you say tensor yet?
With 4-bit integer. All of this so that we could do hybrid rendering and run RTX. Well, so the question is, how does this all turn out? So if you look at the performance, it looks kind of like this. So Turing is built for RTX. And if we ran, the first thing I showed you was originally ran a GDC was DGX with 4 volts, 55 milliseconds. 55 milliseconds, about 20 frames per second.
Oh, Wings Cancer thinks that the number
and this is
to call earlier was the price of the RTX 889.
One Turing.
That'd be funny.
So 4 volts in a DGX.
Almost as fast as 4 volts. For ray tracing.
For ray tracing.
This has never happened before. This has simply never happened before. Doing computer graphics, essentially a supercomputer replaced by one GPU within one generation. Of course, it took us 10 years working in parallel. If you were to look at Pascal, this is what Pascal looks like.
I'll say Maxwell, please.
The fastest GPU on the planet. Wow. The fastest GPU on the planet today, 1080 Ti, 308 milliseconds versus 45. Basically, about 8x.
It's built for ray tracing.
So the question is, what's happening under the hood? This is a new computing model, and so there's a new way to think about performance. It's a new computing model, so there needs to be new metrics. Back in the good old days, the vast majority of computation was done in shading. We're basically shading the color, or we're running a program in the shader,
says,
and basically we're shading.
Time,
but
so
in the future,
was better. Oh wait, no,
we're going to be doing lighting. We're going to be doing all kinds of image processing, and so the pipeline is completely different. And if a pipeline is different, the platform software's got to be different. The architecture of the GPU has to be different, and you have to measure it differently. We have a new way of measuring.
It's a global
and let me talk to you about how we're going to do that.
Yeah.
So if you look at this frame, this is abstracted, of course, but it's not too far off. Basically, within the frame that I was showing you earlier, we're doing ray tracing pretty much all the time. Okay, we're shooting rays all over the place. We're looking for intersections of triangles and figuring out which one of them has to generate shadow rays and which ones of them have to generate reflection rays and which one of them has to generate refraction rays. And for the reflected rays, it's got to figure out how many more shadow rays it's got to generate. And so all those rays are being bouncing all over the place. And eventually, we accumulate the color, the intensity, whether it's directly or from something nearby, and we shade that surface. And so we're ray tracing all the time. And that's with our RT core. That's the amount of time, the fraction of time within 22 milliseconds that an RT core is doing it. Imagine if we didn't have the RT core, multiply that by 10. If we didn't have an RT core, that green bar, just simply in terms of time, is just 10 times larger. So basically, all the way down the street. Shading is shading. We're doing shading incredibly well. One of the things that's really great about Turing Shader is that we can now overlap or run independently floating point integer, and as a result, it's, call it 1.5 times more performant than it used to be. And then that's the integer shading there. And then for DNN processing, when everything is done, we could use it to generate pixels that we haven't finished, to generate using artificial intelligence the pixel that we haven't finished, or use artificial intelligence to generate resolution that we otherwise couldn't have. Okay? It is possible to filter information, but it's very, very difficult to generate new information that looks right. And so with artificial intelligence, we can now, for the very first time, generate missing pixels that are actually right. and we could do it in real time because we have the tensor core. And so if this is what's going on in the frame, then what's happening inside our chip? So the first part of that processing, the shader and the RT core, the Turing SM and the RT core are both concurrently running. Later on, we're shading and generating running other parts of the program, the shader program.
He hasn't talked about motherboard,
those
CPU,
two parts
or RAM.
are running. The FP and the integer. And then finally, when everything is done, we're going to use artificial intelligence. All of our 110 teraflops, 110 teraflops, think of that, is basically 10 1080 Ti's. It's basically 10 1080 Ti's dedicated to doing one thing, which is artificial intelligence. And so if you just simply do the math, you have about 14 teraflops of shader math. You have 110 teraflops effectively of ray tracing. 14 plus 14 independent teraflops and TIPS. And then lastly, 110 FP16 tensor core processing floating point operations per second. When you take that and do the weighted average on it, it's basically 78 tera RTX ops per second. And so the way to think about performance in the future is to figure out a way to weight all of these different types of processors. And so the way we think about Turing is 78 tera RTX ops. Okay? Compare that to a Titan X, our highest end of approximately 12. 78 versus 12.
Hi, Kitty.
When you're running ray tracing, that's what it's going to look like, 78 versus 12. Well, one of the most important miracles, you're going to see a lot of writing about this in the future, is simply the testing. The concept is simple. You're sending a ray into the scene, and you're trying to figure out which one of those triangles out of 100 million that intersects. Well, you could simply just walk across the screen and see which one you eventually touch. Well, you got to go 100 million times. Or what you could do is you create a data structure, an acceleration data structure called a bounding volume hierarchy. Basically, it's like binning. Suppose I had 10 things I got to figure out which one is the one I want. I was asked to go pick something out. I had to go pick one of 1,000. I'm going to put 10 bins or 10 boxes.
I think they're going to tie this to
within
the new
each one of them,
Terminator
I'll have
coming up.
100 things. Within each box, I'll have 10 boxes with 10 things each. If I knew that, if I started looking for that thing out of those boxes, and I discovered that it is in one of those larger boxes, then I can ignore every other box. And then once I find it within the larger boxes, if I find it within one of the 10 smaller boxes, I can ignore all of the other boxes. And then if I can find it within that box, I know it's one of the 10. It's the same idea here. We're sending this triangle, we're sending out this ray, we're trying to figure out which one of the triangles it intersects with. And once it intersects with a bounding box, which is a large structure, which has a whole bunch of other bounding boxes within it, which other boxes within it, and within that there's a whole bunch of triangles. Once we intersect one of the bounding boxes, we know all the other bounding boxes are ignored. And then we figure out which one of the bounding boxes within, and then once we figure out which one of the bounding boxes within, we have to figure out which one of the triangles it happens to be. Well, the amount of mathematics necessary to do this is just shocking. And to do it precisely,
What's in the box?
so that the image quality is perfect, is really, really hard. And took us 10 years to do this. To create the architecture and the algorithm for doing this, design it in a way that actually speeds up, which is very, very hard to do because these beams, all these rays are incoherent, which is the enemy of parallelism. Somehow, we figured out a way.
Oh,
come on, stream, come back.
Sending more triangles.
We just lost the
way
stream.
to make all these incoherent things largely parallel, and then to create an acceleration structure, an accelerator that allows us to do this
be back any
at
minute
the
now.
speed of light. And so the RT core was invented. Well, the RT core invention had to go along with all the software layer on top of it and what we call eventually the RTX platform. At SIGGRAPH, we were really pleased to see research being done in this area. Our researchers and the researchers at the Search for Extraordinary Experience, I love that, SEED, Electronic Arts research team. NVIDIA Research is called NVIDIA Research. EA Research is called SEED. I love that. The Search for Extraordinary Experience Division. And so they worked on RTX with our researchers to figure out how it could accelerate, how it could create new computer graphics. And everything from deferred shading and direct shadows and lighting and reflections and global illumination and ambient occlusion, transparency and translucency. Translucency and transparency are just incredibly hard to do with rasterization.
Well,
because the concept of depth is very difficult to discern.
It's the normal deep dive.
And post-processing, as you could see, for each one of these operations, we're using different parts of the chip, exactly as I described earlier. The effective ops, the effective computational capability, 6 times Volta. 6 times Volta, 6 times NVIDIA V100. And so that kind of puts it in perspective. This new Turing processor, this new Turing GPU is just a monster. It's incredible. Let's take a look at some of this stuff. And so this is what it looks like. This is computer graphics today. Physically based material, direct lighting. You could see the shadows. They're hard shadows. We could try to trick it by blurring it a little bit, but it's still going to be basically that. And this is what RTX looks like.
T&M says you're early, so. Elena.
Oh. That is nice looking.
Hey, you got to clap at the old stuff too, because it resembles us. So here we go. I'll give you a chance, guys. This is where we came from. You got to be proud of it. You got to own it. It's ugly, but you got to own it. Before, after. Before RTX, after RTX.
I like the little reflections on the ground.
And that first ball is translucent.
Oh, no, this is just the beginning. I'm just warming you guys up.
Yeah.
I just gave you an olive for the appetizer. Okay, can we show him some stuff? Nacho,
Hi.
Is it you and me?
Yes.
Okay, so this is Nacho. He's one of our dev techs, incredible computer scientist, amazing computer graphics engineer. This is what he was able to do with RTX off. RTX off. Now, of course, this scene is incredibly hard, and the reason for that is because you can't use tricks like screen space reflection here. You could put some reflection probes, but it's just incredibly hard here because things are being reflected all over the place. There's refraction. You see that graphics card back there? That's a beautiful graphics card. I announced it a week ago. That's called the Quadro RTX. And you got this crystal ball here where it should reflect and refract. There's a little green ball on the ground there. And then there's that chrome ball in the back and this empty, I don't know why, but empty glass box. And it's got area light coming in, which is really hard to do, okay? And so in this particular case, Ignacio is doing his best to emulate the area lights, but the shadows are ugly. This is the limits of today's computer graphics. Now, we could fake a lot of stuff. We could fake a lot of stuff by arting it up. It
still doesn't look too bad.
Cause you to not look at it.
It
but in
does
the
look
final
nice.
analysis, this is what the limits of today's computer graphics is.
Huh.
Now, Ignacio, let's turn RTX on.
Oh.
That just looks real.
And I'm guessing in limits means you couldn't do that in a reasonable time.
So let's take a look at RTX on. Look what happens. The refraction of the glass globe there is just incredible. And look at this, the little caustics on the ground. The area lights cast a soft shadow.
It just feels like there's so much more depth now.
Notice of the graphics card.
I didn't even know there was a
the
glass
shadow
box.
Of
I know,
the
me
chrome
too.
ball looks right.
I didn't see it.
Now there's reflection of the glass box in the RTX, Quadro RTX. You see Quadro RTX from that sphere, and you see the reflection of the chrome ball with a little bit of rough surface to give you a sense of material. Everything just kind of looks right. Even the glass is casting a shadow. Even the glass is casting a shadow. Hey, let's go back to the last one again.
Currently, no pricing, no availability, no model numbers announced.
Oh, really?
Nothing.
Yeah. This is the normal. This is you got to take your medicine.
The chat was right. I really
now,
didn't
of course,
miss
we got to add a
anything.
whole bunch of paint and a whole bunch of stuff to make it look
plenty of
right.
interesting stuff about
or
how
we
it
could
works,
do it this way.
Oh.
but not
RTX
about what
on.
it is
Yeah.
and how much you can pay for it. You did make a joke about selling that box with the 4 Voltas in it.
Yeah.
And there was a gasp in the audience. But this could possibly be a photograph, right? Nacho, show me what you got.
Oh.
Oh, come on. Okay.
The glass ball is
Pretty
cool,
incredible.
though.
You have to
lighting
turn on a
sources.
spotlight on top of that.
Nice.
Everything just works. Everything
Wow.
just works. Look, glass
Wait, is this an
reflects
NVIDIA or
and
Apple
refracts
conference?
and magnifies
Is this
just like it's
He
supposed to.
said it just works.
And you just have to turn it on. And so the benefit of RTX is just turn it on. Thank you. Good job.
Nice.
Just wait for it. This is the basics, fundamentals. There will be a game demo of this, and people.
And so
are
now I'm
going
going to show you something. We're going to turn it all together. We're going to put it all in. We're going to put it all together. And it's going to be a demonstration that we created recently. We created recently to highlight the power of NVIDIA RTX, this mixed mode rendering, unifying rasterization, ray tracing, compute, and artificial intelligence. And what you're about to see is completely in real time. Everything you're about to see is completely in real time. It's kind of hard to grok because it's going to be so beautiful, but it's completely in real time. You're going to see beautiful reflections. You're going to see inter-reflections, reflections of reflections, and it's all going to be dynamic. You're going to see beautiful lighting.
Oh,
You're going to
show
see
us
area
Doom
lights.
Eternal.
You're going to see beautiful ambient occlusion. You're going to see beautiful physically modeled materials. So things that look like metal looks like metal. Things that look like things look like things. That's
pretty
very
good.
technical.
I do like that. I like that he caught himself.
And that's how I talk to the engineers. Guys, we got to make things that are things look like things. And they go, I know what you want, boss. And so what's in here is just really a miracle. And it's running on one Turing GPU. It's running on one Turing GPU. Ladies and gentlemen, the name of our demo is called Sol, S-O-L.
Something with the sun, huh?
Should be cool. I've not hit bingo yet, but I've got at least one that could hit. He just needs to say quantum.
Okay.
Did you say this was in real time?
Yes. Wow. Well, he didn't say that, but it's guaranteed this is real time.
Oh, I like the reflection of the beam on that.
Wait, it sucks if you got to scratch your feet, though.
I know.
I've got an itch.
That is just beautiful, though, right?
It's
That-
beautiful. Still doesn't look, completely realistic, but it's beautiful.
Yeah, but impossible to achieve with what we have today. in
No,
real
it's
time.
true.
Impossible.
It just looks a little too perfect right now.
Yeah. That's the problem with one fault, though.
That doesn't look like the Doom guy. Dang it.
Yeah, what happens if you get an itch somewhere?
Don't worry about it. Just drive you crazy.
Man, it's making me want to scratch right now just thinking about that suit. What?
Wait, what?
I like the humor there.
Portal 3.
It's 5 o'clock. Shift's over.
What do you guys think?
All right. Sure.
All right, that is...
The NVIDIA RTX. NVIDIA RTX running on top of a Turing GPU. Hybrid rendering, real-time ray tracing for the very first time. That's the first part. Deep learning is the single most powerful computer technology that has come onto the scene in the last 30 years.
Elena.
Deep learning is a field of machine learning where using a large amount of data,
and Wings
you could
Cancer
train
on
a
Twitch
supremely
thinks that it's
large
a hint.
neural network how to do things.
Slack.
You train these neural networks with all of this massive amounts of data, which is otherwise examples, on supercomputers. And this is the reason why voice recognition, natural language understanding, photo tagging, image recognition, all of these amazing
cognitive
feats of software are now finally possible. It is the reason why self-driving cars is even within reason to fathom. Deep learning is changing one industry after another. And people consider this the fourth industrial revolution. It is going to enable AI and computers to write software by itself, to basically run on a supercomputer, to write software by itself. At NVIDIA, we're doing all kinds of research around deep learning. We have a gigantic supercomputer that all of our researchers use to develop software. Now, some of the things that I'm showing you some examples here. These are some of my favorites, but there's so many. For example, you could teach a neural network how to colorize by just showing this neural network examples of, this is a black and white, this is how you colorize it, this is black and white, this is how you colorize it.
Yes. Oh.
It eventually learned what the pattern is, and you can give it a black and white image, and it colorizes it. You could give
link to our bingo game.
You could teach a network how to take a low resolution image and make it higher resolution. Because you and I could look at this image and say to ourselves, you know what? I bet I know what pixel each one of those pixels are. And so you could use a low resolution image input and eventually get an output of a high resolution image by going the other way, which is starting with a high resolution image and give this neural network the opportunity to generate that, and whenever it's wrong, you correct it using this thing called stochastic gradient descent and backpropagation. And so you literally correct it, and it tries to guess and guess and guess, and it corrects itself until one day it's able to figure out what pixels to generate. You could teach it how to take a cartoon and turn it into live video. This is a piece of work that we did in NVIDIA research.
Jensen is a real-life Miles Dyson.
Taught it how to do that.
That's pretty good.
Pretty amazing, right? We could teach it to take a low-resolution CT scan and not only increase the resolution of it, but also segment it, figure out what organ is what from that blurry blue image.
Enhance.
Okay, you watch this. We taught it how to segment, how to identify which organ is what, and put a different color around it. Pretty amazing. This is going to revolutionize medical imaging. We have a platform called Clara. It has the ability, you could teach it how to go find identical twins. Come on, you guys, that was funny. I don't
missed it.
This is what we taught it to do. Change the color of the hair.
That's actually pretty amazing.
All in real time.
In real time, that's amazing.
That's
previously, you would have to find identical twins to do that.
Yeah.
Well,
much harder.
Not necessarily.
Now you could do it with an artificial intelligence network. You could take a sketch and turn it into 3D.
Oh my God, it's Mario 64.
I would really like that.
So you take this neural network You give it a whole bunch of examples. You tell it what is the input and what is the exact expected output, and we give it a chance to try and try and try and try again, trillions and trillions of times on a supercomputer. Eventually, it trains and does this amazing thing. And then it creates this neural network model with hundreds of millions of parameters or hundreds of gigaflops of operation necessary to perform its task, to either classify, to predict, to draw, to generate, to imagine what color looks like. We could teach it to do these amazing things. However, there are so many architectures, and it takes so much processing to do it in real time. And so we created this thing called a tensor core. There are a whole bunch of them in our chip. And imagine this, okay? Imagine that a 1080 Ti is 1080 Ti is what, 11 teraflops. A full 1080 Ti, a full 1080 Ti at $699 is 11 teraflops. This is 110 teraflops. Basically, it would take 10 full 1080 Ti's to keep up with the tensor core processor that's all over the Turing GPU. Now, one of the things that we taught it to do is something really incredible. And so we taught the neural network this thing, and we're calling the NVIDIA DLSS, Deep Learning Super Sample. Basically works like this. We create a whole bunch of super, super high resolution images with lots and lots of samples. So we jitter it, and we create basically 64 amazing images, and we create hundreds of thousands of those. And then we give our network, we put an image in here, and we say, using this, it's called an autoencoder, convolutional autoencoder. It has to be temporally stable because we want to do this for live action. And so the network has to remember part of the past. And we're going to give it an image, and we're saying, go generate this amazing image on the output. Okay? So pretty soon we'll be able to give it a new image it's never seen. We train it, and every time we train it, if it guesses wrong, we tell it what's the right answer, we propagate it back. It takes another image, it guesses it again, and if it turns out to be wrong, we propagate it back. And we sit there and we just simply loop on it on a supercomputer. We run it trillions of times. And then eventually you put in an image, and it creates this beautiful image out. You create you take an image of lower resolution, say 1440p, and it creates this beautiful image that's 4K. Now, of course, the question is, where did the images come from? Where did that come from? Where did that magic come from? It came from partly a supercomputer. Essentially, what deep learning is doing is codifying the memories of a supercomputer, and it puts it into this neural network, basically an image generation brain. And you put this image generation brain, this neural brain, into the mathematics of our GPU. All of a sudden, it knows when it sees this image, a better version of it is that. And it sees a new image, a better version of it is that. That mathematics came about, the weights of those neurons came about because of a supercomputer. And so in the future, every game would have had the benefit of supercomputer pre-processing before you play it. And we call that platform the NVIDIA NGX. In the future, computer graphics will merge with neural net processing. We call it Neural Graphics Acceleration, NGX. It's a framework for doing all kinds of amazing image processing. You saw earlier super resolution. We've invented super slow-mo. We're going to do all kinds of amazing things that makes video games and the images that come out of these computer graphics, CGI, look even more amazing. Basically, it works like this. We have a supercomputing infrastructure. There's a whole bunch of software that runs on it. The first thing you do is you generate ground truth. What is the perfect image? What is the perfect image? And then we have to train this model. It's a multi-dimensional manifold, and we're basically randomly walking around this manifold looking for the least error, looking for the time when you send in an image, the output is closest, your predicted output is closest to what ground truth is. okay? That your prediction is the closest to ground truth. And you're sitting here wandering around this gigantic universe, and it's incredibly, incredibly large. And so the computation time is very, very long. And that's why we build these supercomputers we call DGX. I showed you earlier version, the desk side version with 4 GPUs. These ones have 8. And then we test and optimize it. Then you put in a low resolution image or lower quality image, or the image is in fact not even complete with ray tracing, and somehow we complete it. Somehow we make it more beautiful.
Hard OCP is reporting some
the
prices.
NVIDIA NGX. And then we have this AI model
600 for 270,
that we then
800 for 2080,
OTA to you. You download it into your driver, into this
2080 Ti.
plug-in interface called NGX. And the neural networks are changing all the time. They're getting better and better. And we put it up in the cloud, and you could decide whether you want to enhance your images or not.
Yes, cloud.
Then you run that on Turing. NGX driver. This is all part of the RTX platform, and you run it on the chip. Well, the supercomputer looks like this. This is the machine that is generating all of those networks. And basically, before you even run it on Turing, before you even run your game on Turing, there are a bunch of supercomputers. Here's one. There's a bunch of supercomputers that's training these models.
Hey, we got somebody who got a bingo.
And the graphics card, here's one.
Nice.
The graphics card, you guys know what a graphics card looks like, right? Here's one.
There it is.
Available retail.
2080.
$68,000. Okay.
Should use that image for the website.
I wonder how heavy that is.
It's like
got to keep your abs tight while you're doing this. A whole bunch of interconnects, SerDes interconnects called NVLink, connects all of these GPUs together into one virtual GPU. Every single GPU can see each other's GPU memory. All together, this board, that system has 2 of these inside. Yikes. 2 of them.
Wow.
This is 1 petaflops. That's another petaflop.
So it's running an SLI?
Not motherboard, but mother.
No, they're.
God, it's heavy. GPU.
God, it's heavy. Did
2
you hear
graphics cards. Makes 2 petaflops. 2 petaflops. You want to put 2 petaflops is basically a supercomputer with servers from that side to that side.
Up there. I do
400
like
servers.
Awesome.
$2 million without anything else of servers. This replaces. And so we use this to train the neural network model. Here we go. Here.
It's heavy.
Somebody take this.
You can do it. Thanks, Paul. You use that, and you train this network called the NVIDIA DLSS.
Somebody just said Ray Ripper.
And then
they're going to call it.
Comes up with a model like this.
I like that.
Yeah.
And this is 4K TAA. You guys know the Unreal Engine Epic's demo called Infiltrator. It's just beautiful. Incredibly taxing on systems. And 4K TAA up there. TAA is the anti-aliasing technology we invented, which is temporal.
I guess prices
temporal,
are live on the
website. It takes last frame, the motion vectors, and it tries to figure out what's the best combination to create beautiful edges. Look at that, because it's temporal and the motion vectors, so many things are moving. You see a disjointed hinge over here. And this is 4K DLSS. Look at this.
I just put it in chat or Slack.
That's just perfect. Okay.
Yeah, it looks like those are the prices.
Well, for the very first time, because of this, because we could take a lower resolution image, and because we could train a neural network with all kinds of super high resolution and super high quality images, this neural network, it runs on a...
Where's this source from?
Bat out of hell processor called a Tensor Core.
It's NVIDIA site.
Could then in real time enhance images. In real time generate pixels it had never seen before. Generate pixels that make sense to go there, because if you and I were to look at it, we would know what makes sense to go there, and therefore it makes sense that we could teach a neural network how to make sense of what pixels to put there. So I'm going to show you something. This is Infiltrator.
This will ship on or around
running
September
on
20th.
1
limit 2 per
GPU,
customer.
Of course.
at 78
So if
frames
you're tuning in,
per
the
second
NVIDIA website shows the
in
price
4K
of the RTX 2080
at
Ti.
a quality that has never
$1,200.
been seen before.
Wow.
All on
A
available. in
1080
September
Ti, the
20th.
fastest GPU in the world, can currently do about
Looks like they're
30
going to show
something.
Battlefield 5.
Okay, from 30 something, what you're about to see is 4K. Now I'm going to lock it to 60 hertz because this display happens to be V-synced. And so you're going to see the frame rate on top.
Oh, frame
and
rate.
ideally,
Oh, bingo.
it's pretty high. Very first time
I was waiting for frame rate.
to see Infiltrator running at 60
Oh.
hertz
Trying to
in 4K.
hit the shop link on the NVIDIA site gives you a 502 error.
What's 502?
Bad gateway.
It's not open yet.
Yeah. Specs are interesting though. They're already up.
Yeah, 11 gigs. DDR5.
So I'm going to talk during this demo part. RTX
DDR6,
2080 Ti, $1,200, available in September. RTX 2080, $800, also available in September. RTX 2070 for $600, no availability.
What did the 1080 launch at?
650, I think. Ti, the 650 Ti was like 650, which is a crazy price.
Really? The 1080 Ti was 650?
Yeah, because remember it blew away.
Yeah.
Just destroyed the existing.
So this is like almost double the price, pretty much. Oh yeah, because the 1080 was 500, right?
Yeah.
Is that amazing? It's just silky smooth. Silky smooth. One Turing GPU.
Oh, no brainer.
One Turing GPU, twice the performance of the highest end GPU in the world today, 1080 Ti, running at 4K with beautiful image quality. Well, you know, we should probably at this point take a look at what Turing does and RTX does for games. You guys want to see some games?
Yes, please.
Yes.
Battlefield
Kata.
5.
What do you have for us?
Yeah. So,
You need your mic on, sir.
oh, testing 1, 2.
Yeah.
So,
Ladies and gentlemen, Kata,
all right. So first up, we have
head of our developer relations. We work so closely with developers all around the world. We work with them to improve new
What kind of run the
technology,
Bayonetta?
create new technology, and optimize their games for our platforms and push the limits of what's possible in real-time computer graphics. And the work that we all do together it just brings me so much joy. And we got this amazing developer relations teams that works with them and dev tech team and all these computer scientists that work with them. And man, it's just so great. I love you guys.
in my 17 years here, Jensen. Our entire team has never been more excited over a new technology, a new product, than with Turing. And also with the developer reception has been phenomenal, and we're just so pumped. It's really an honor to be here to, deliver.
Kata, you know what?
Games.
I'm going to give every DevRel and every dev tech in our company a new Turing.
Oh my God. Oh, oh.
Just look under your seat.
Thank you. Wow.
The number of people in that group, I'm sure has
Somebody in the
increased
back
by
is
a
like,
factor of 10
crap, do
since
we
I
have
said
that?
that. Okay, what's the first
All
game
right.
we're going to talk about?
So Shadow of the Tomb Raider is the first up. It's the latest and the really, obviously, not much needs to be said. It's a super successful franchise. Just data-wise, it sold 65 million units, and it's going to ship the Shadow of the Tomb Raider on September 14th. This time, the game has Lara Croft going on an epic adventure in Mesoamerica and South America. Just one thing to note, a parallel, Lara has a long and illustrious history. And actually, in many ways, Lara and NVIDIA has grown up together because we both
Never thought of it that way.
Yeah, in the mid-'90s.
Yeah.
And in fact, Jensen, it happens to be the first game I played when I bought my first Riva 128 in 19.
I was 30 when she was 25. Grew up together.
So yeah, so we work with Crystal Dynamics, Nixies, and IDOS Montreal, and we're excited to be able to show it.
And now what we're going to feature, we're going to show just a little part of it. Then later there's an after show, and there's the developers are going to talk to you about all this. You're going to be able to see all this stuff, but we're going to show you just a few things about it. So one of the things, of course, Lara Croft, you're in shadow all the time. It's all about shadows. And one of the challenges with shadows, as you know, they're just using traditional shadows. They're too crisp.
Lara Croft.
And so they have these hard shadows.
Lara.
And if we use contact hardening and we use percentage closeness shadows, they're kind of blurry and fuzzy and noisy. And when you put a whole bunch of them together, it just becomes a big mess. And so what you're looking at is ray trace shadows. And you're going to see a lot of ray trace shadow stuff, and that's the first demo we're going to show you. We're going to feature ray trace shadows. Go, take it away, guys.
Hey, my name's
Chad.
Hey, I'm over here. And apparently I work in the DevRel team with Kata, and apparently I just got a new Turing, so I'm really excited.
Bingo.
So what we did is we worked with Nixies and IDOS Montreal to bring real-time ray-traced shadows to Shadow of the Tomb Raider. It's perfect.
And so the thing to look at right now with RTX off, you saw the crisp shadows up there, and you saw right here. This is really hard to do, and that's why they don't do it at all, which is dynamic lights and shadows.
These are dynamic point lights. They're really expensive to do in current rendering techniques because basically you have to cast shadows in every direction from the light. And this goes back to what you were saying earlier about having to put a cube map here and a cube map here, and every time you move, you have to redo all that rendering. So let's put RTX to the test and have it just do it for us.
Aww.
Nice.
The beautiful thing about ray tracing is you turn it on. You know, when you turn on the light, it just does the right thing physically. And because we're tracing these rays physically, it should perform according to what we expect.
Yeah,
and so the umbras, where right behind, where it's nice and dark, it's correct. And where penumbra, where you have the softness of the shadow, because not all of the shadow is occluded, part of it is lit, you get some softness.
It's like you're offloading the shadow work on
off and on.
Wow.
Now let's take you to, you were talking about some of those area lights earlier. You want to look at some examples of those?
Yeah.
Well, here's a big example. This is an incredibly lit scene. This whole scene is amazing. It's beautiful. And so what we have here is we have two cone lights and two area lights. Those area lights are basically rectangular shapes, the neon lights above the stage. And what you notice is the shadows below are hard, like you keep talking. And this is state-of-the-art for real-time graphics right now. And I got to say that because the guys are sitting right next to me who made those shadows. And they are, this is the best we have right now.
And they look beautiful.
Yeah, they look great
until now. And the way that's simulated, those area lights are simulated essentially as a couple of point lights. And that's why you see such hard shadows.
Exactly.
But if you simulate the area lights like area lights, because we ray traced it, and independent of where the rays bounced around, eventually, if it were to hit some part of that area light, it gets lit. And so ray tracing is a much more cost-effective, in fact, however, very difficult to do, way of doing area lights.
And let's turn this on and take a look. So you get the nice blend of the color and the light.
Isn't that beautiful, guys?
In the distance from the shadow source. Like it starts to fade out.
It's like
harsh.
And we can do whatever we like. We could add more area lights. We could add more spotlights. You can mix it all together without trying to fidget with it, without trying to figure out what is the definition of right. Right just looks right.
Yeah.
That's another
It's
wisdom.
funny, little
right
things you don't even
right.
notice till.
And talking to the artists that do this, they tell me all great things about shadows. They're telling me shadow is another color to them. They love shadow. And they also told me that shadow and light is what they use to set the mood and tone of their environments. And so that's how important shadows are. And it feels like we just gave them a lot more depth for it.
Cool.
Some more on, more off.
Okay. What you got?
Well, we want to take a look at some more area lights that are very interesting.
Let's take a look at one more shadow.
All right. One more shadow.
Oh.
What is that? What is that?
It seems like it's from their end.
What?
All right, so we're trying to get the stream back. So just if you don't know, it's already on NVIDIA's website. Jensen has not announced it yet. But RTX 2080 Ti, I'm going to give you the specs. 11 gigs of RAM, 4,352 CUDA cores, base clock of 1350, 352-bit memory bus. And let's see, for power, 260 watts, 8+8 configuration. Oh, we're back now.
That's for the Founders Edition.
That's for the Founders Edition 2080 Ti.
Let's take a look at an exclusive trailer of the Shadow of the Tomb Raider.
We just missed a little demo. That's it.
What is that?
Hayden and I played a little bit of this at E3. Not with RTX on, right? Obviously. Vignesh says so much for AMD supporting Tomb Raider in the past. Matthew says pre-orders are up on the NVIDIA site.
Yep. Are they actually live now? Elena checked earlier and they went nowhere.
Let me see if it was working for me now, but...
That's awesome. I can't wait. That's going to be a wonderful game. All right, what's up next?
Well, another blockbuster, and this time we have Metro Exodus by 4A Games.
Yeah. Oh, man.
Yeah.
It looks like they're pushing people to Amazon, Best Buy, and Newegg now.
So for those of you who don't know, it's the third in the Metro series. This is set to take place in 2036 in the post-apocalyptic wasteland of the former Russian Federation. You guys know this. It's been
Matthew
super
said he
successful.
got his order in.
In just 2 versions of the game, they've sold 7 million units. And this one, Metro Exodus, is due out February 22nd of next year. It's going to be well worth their wait. It's developed by 4A Games, who, since for the first time we met with them, Jensen, back in 2009, they're super enthusiastic and very forward-thinking. So we're not surprised that we have them here today to show something awesome.
Yeah, that's really cool. Now, the thing that we're going to showcase with this demo here is something that is just really, really hard. Basically, the way light works is, can you guys see this? My light is really bright, but basically, light is coming in from the outside through those windows. And of course, this part is lit directly. And the challenge here is that's an area light, and so we have to make sure that the shadows look right. Off. However, that light doesn't stop there. That light bounces around this room, and it illuminates different parts of the scene, depending on how close they are to that particular light. And maybe in the creases and the corners, it's really super dark, but in other places, it's more light, and direct light, it's completely bright. And so lighting this room using traditional computer graphics lighting is just incredibly hard. And this is the perfect showcase for global illumination. Now they want to use light, of course, to create these incredible moods. And so you feel, a little scared when you walk into a room, instead of being completely black, which is not right, or completely lit, which is not right either. And so global illumination has the ability to create an aura, a feeling, a sensation that is really photoreal. And so this has been something that we've been pursuing literally for a long time. This is a 10-year pursuit that we have finally been able to do, global illumination. Let's take it away. So Matt, this is GI. This is GI on. And so just as I was describing earlier, the light is coming in through the window. It's bouncing around inside. And as a result, we're lighting. Look at that. That corner is darker. That corner over there is completely dark. And that light right above the windshield is nicely lit. It does exactly what you expect it to do. And it does it all by itself. Just put sunlight outside. super high intensity ambient light. Put it outside and everything just works. Everything just works. Now you could do it the other way. No, go to direct light. You see this? This is the way computer graphics basically works. Now, of course, we could create a whole bunch more fake lights. We can create a whole bunch more fake lights. But in this room, if you created more fake lights using spotlights, you'll get all these different areas that are lit too intensely and others that are not. And it looks like you basically turned on a whole bunch of lights. Now, what you could do, and what Matt did earlier, is turn on basically a artificial global illumination light, which is basically a fake ambient light.
Yeah.
It's like somebody comes in here.
It doesn't look good.
No.
Instead of allowing us to light this room with global illumination, which is happening right now from these monitors, like for example, I'm being lit by the monitor, and you guys are all being lit by this screen, this 4K gigantic, beautiful screen.
What was
and so the entire room is being lit with indirect lighting. But here, because we can't do indirect lighting back in the past, as in yesterday, we had to put a fake light in here. It's like somebody comes in here and put a fake light and constant intensity, constant color throughout this entire room. As a result, the places that should be dark, like back there, isn't dark. The places that should be more bright is the same intensity. Okay, which is what you're looking at now. So this is wrong, and let's look at right. Look at that. Delightful.
It's really interesting to see the difference between our monitors in here.
True.
Like the TV is too dark, period.
So Matt,
even these two
our friends
monitors
are now
different too.
able to have like creepy monsters literally squatting in the corner.
Yeah. Take a look in the rafters in the ceiling. When RTX is on, they're black. I could hide anything in there. But if I'm lighting it ambiently, you can see everything up there. When we have RTX on, it's correct. There's no light up there, so we can actually hide things in. We can make the mood and the environment perfect by just letting the normal light in the room.
Games will never be the same.
No, sir.
So scary. All right, good job. Thank you. Let's take a look at another exclusive trailer, shall we? Metro.
Ooh.
I'm going to talk over this, just to let you know. So we're over. This is awesome, real-time trailer. But so we have 3 cards. Jensen has not officially unveiled it, but it is on the Vertigo website. $1,200 for the 1080 Ti, $800 for the 1080,
2080,
and $600 for the 2070. 11 gigs, 8 gigs, and 8 gigs, all GDDR6. 8-pin power on the 70 part.
And 2 8-pins for the...
Two 8-pins for the TI part, and then a 6+8 for the 2080. The 225-watt TDP on the top end.
2070 is already sold out.
On the 2080. 260 for the TI. For the TDP.
For the Founders Edition.
The
reference spec says 250.
Yeah. And then 175 for the Founders Edition 1070. The 2 top-end cards support SLI with some new...
A new bridge.
New bridge. I think it's the NVLink, and the bottom-end one does not support SLI.
$80 for the bridge.
Wow. That is incredibly scary. I don't think we have enough arrows. Okay, I want to flash through a couple of them, and then in the after show, we're going to show it to you. I want to save time for a whole bunch more stuff. Okay, let me show you. Assetto Corsa Competiziano.
Yes. These cars are going to look good.
I spoke 2 languages today already. Okay, when you guys see it later, I want you guys to look at some stuff. Okay, first of all, the reflection on the windshield. You guys know how screen space reflection works. If it's not on the screen, there's no way to take that image and reflect it onto the surface. And as a result, look at the glass on top. You see that car? You see the Ferrari up there? It's reflected on top. All of the rails all the way down are reflected. No errors, no weird banding, no weird distortions. You see this guy reflected from the other side. So when you go see it, he'll be moving and everything will be dynamic. When the cars come through, you'll see all the reflections up and down this aisle of the cars with other cars, the cars over the window. Everything is going to be completely dynamic and nothing had to be tweaked. Ray traced reflections and ray traced inter-reflections. Cars are going to reflect each other. If you look at the railing, the shadows are just rendered beautifully, the soft shadows, because the world is one big area light. And shadow map precisions are just not good enough to go all the way down there. And yet, for ray tracing, it just works. In fact, if you see the final game,
he does keep saying it
the
just
shadows
works.
Of the last buildings are completely gone.
He keeps saying
you're going to see reflections of the toolbox.
It makes me think Apple.
That's what I said earlier.
Garage and the car in the garage.
Of implementing in it.
Everything just
I would hope so.
Global illumination just works. Ambient occlusion just works. All of the soft shadows
I think also that it just looks normal too.
And you can look through the window, and depending on the angle of your view, you'll see Fresnel reflection. So sometimes you see perfect reflection, sometimes you'll see through the car. Everything just works because ray tracing just works. You're going to see another game called Atomic Heart. And this game is just really interesting. And it's got wonderful reflections and refractions. And mirrors are curved. Curved mirrors. Nobody does that. It's impossible. Not for ray tracing. It just works. You get this area light underneath, casting that soft shadow for the robot behind it. Everything is physically based. All the materials are rendered beautifully. And so area lights, reflections of the scene that you can't see in the scene. So screen space just doesn't work. And yet everything just works here. Well, guys, I want to show you something that's really cool. You guys want to see an amazing game? I can't wait for this. This is probably one of my family's favorite games. And this is wow. Guys, I can't wait.
Yeah.
Wow. So that means they're actually going to support some form of ray tracing in Battlefield 5?
Well, yeah, on that page it has that little slider.
I think we have with us Jonas and Christian from DICE. Guys.
Hello, Jensen. Hello.
Some of the brightest and the most amazing computer graphics engineers in the world. We've been working together on implementing RTX into Battlefield 5. Now, you guys, the anticipation of Battlefield 5 is so great, I don't think I need to introduce what is the concept of Battlefield 5. It is a World War II FPS. It is part history, part travel, part time travel, part running for your life, part destruction, real-time destruction. You've never seen destruction like there is destruction. Isn't that right, guys?
Correct.
You guys know destruction.
We do.
You guys know how to blow it up. Okay?
Levolution.
There's
awesome.
mayhem. There's
Call of
chaos.
Duty players.
You work as a team. You can battle by yourself. I want to go learn all kinds of stuff about World War II by going through your game. I just want to be a tourist. Turn on God mode and go through as a tourist. So we're going to show you some pretty amazing stuff. Isn't that right, guys?
That's
all
right.
Okay, Jonas, let's go. Take it away.
Yep, Christian.
All right. Thank you, Jensen. Thank you, NVIDIA, for hosting such a great show. This is really cool. I'm Christian. I'm a tech director for Engine Group at DICE, and next to me we have Jonas, media and video editor. We're here to show you our implementation, our vision, our take on what RTX can be, and we want to show that in our brand new Battlefield 5. And in the setting, we'll take a look at our brand new multiplayer map, Rotterdam. And it's a really dense and cool city map. We'll start here in a very zoomed in view of the soldier's eye. And we're going to observe something that we've never really been able to do before. So we at DICE have worked closely with NVIDIA engineers over the past year to get to the point where we are now. And we're so proud and thrilled to be here and show it off to all of you. So Jonas, I'll leave it to you. Take it away.
Yeah. So what you're seeing there is a tank firing off screen, being reflected in the character's eye.
Now, you guys know this is not possible with screen space reflection, right, Jonas?
That's pretty cool. Exactly.
Because the fire is not on the screen.
So now if we turn around and we then see the environment, we can see that the tank muzzle flash not only reflects in the eye, it reflects in the entire environment in the tram windows there and within the tank itself, moving here.
Wow. Nice.
So now if we keep moving forward, yeah.
I don't know about that.
That's great. So of course, one of the big challenges of SSR is also complex surfaces like this. So now with RTX on, if we set off an explosion behind the tank here, but next to the car.
Oh, come on.
Reflecting accurately within the car.
Did you see that motion wave from the explosion?
Yeah, and that's what's on
That's
their
impossible.
the website. They have a little slider showing the
How
side
would
of
you
the
do
car.
that with RTX off?
Yeah, how does that look? Like this here. So let's, yeah.
Wow, that looks
on.
incredible.
And it's of course it's updating dynamically everything.
Reflections will never be the same again.
Car this clean.
Look at the reflections off the ground, guys. It just.
Yeah, so you can see.
Wow, it just happens.
With SSR, if it's in the screen space, you still get some of the reflections upon the car, but due to the nature of SSR, it disappears as it goes away. But because ray tracing just works, you just get the expected result, how you'd think you would see it. So the next thing we have to show you is the big, scary crocodile tank, the Churchill. And if we make that one shoot, it's flamethrower across the scene here. Then we will again see that reflecting upon the surface and on the soldiers battling it out here in Rotterdam. So now if we look down in the ground with RTX on, we'll see the flame, we'll see the soldiers moving, we'll see everything. And now if I turn RTX off, we lose everything. We lose all the detail, all the context of what's happening in the scene. But with RTX on, you just get a much more cohesive image and a better understanding of what's happening around you.
That's a flamethrower.
So one thing we also pay particularly much attention to in Battlefield is just the weapons, accuracy, making sure the smallest detail is correct. And you can see even there, the flames are reflecting properly in the wood of this gun here, in the windows in the back. And now if I turn RTX off again, you lose all this detail. So,
wow.
Really cool.
Now, Jonas, what you guys have done is all of your guns, all of the objects are modeled physically.
Exactly.
It's physically based. And so the gun has wood, which is diffused. It's a dielectric material. You have metal, which is reflective. The metal has substructure in it, microstructure in it, so there's some roughness in it. And so
here's a link to
without doing anything at all, because it's physically based, we shoot a ray into that scene. It intersects with a triangle on that piece of metal on the site, and it figures out, I need to boink, generate another reflection ray, and it traces its way to the flame which is coming by, and when it comes by, it accumulates on the surface, it shades it perfectly all by itself. Ladies and gentlemen, the magic of ray tracing.
Exactly. And there's more. So what you see now are objects that are really close by, but ray tracing works for more yet. So up here we've got two C-47 airplanes. They've been shot down. They're crashing with their engines on fire.
Oh, Lord.
So now if we go over to the car here, and you can also see the flame reflecting in the car nicely over there. So if we keep moving forward and then look down on this reflective car right here, we will still be able to see the plane. If we move back here, we can see the plane reflecting in the car. If I move this lens flare.
Wow, your lens flare works
right
good.
There, yeah. And then with RTX off,
I love it.
Everything of
it. Look at that.
We can keep moving forward.
Wow. And Jonas, you guys did a great job with Fresnel reflection. Look when the angle is just right, it's just a perfect mirror. It looks beautiful.
Exactly. So here it's a good example on transparent surfaces with Fresnel and PBR rendering. The more of an angle you're at, the stronger the reflection gets. And now with what we had before, on these ones were just cube maps, which they're also static, but with ray trace you get a lot more detail. You see the entire environment. And of course, as I said, the old school cube maps, they are also static. So say that we were to destroy this building here, make a tank shoot it, with ray tracing on, you'll be able to see Frostbite's and Battlefield's destruction system within the window, moving dynamically.
Wow.
And now, to end it all off, RTX, I mean, it works on the entire scene. So what if we were to shoot off a V1 rocket here?
What if?
And zoom out,
Somebody
get a
just
good
said that
view
lens flare just sold
of the
1,000
entire
cars to
street
Jason.
of Rotterdam, and then take a look at the windows, all the places that you would expect to reflect. For now, turn up the time again, and we just wait patiently for the V1 to hit the ground.
As you do.
And there.
Did the plane really have that much fuel?
It was a V2. That was a V2 that
That's
came
awesome.
down.
That's great.
I'm
Good
not
job,
impressed
you
by the
guys.
flame
Good
effects.
job.
Maybe it's just early.
That's
but
really great. And it's amazing what you guys did so fast. I know you guys worked super hard, but it's amazing how you guys implemented this stuff so
in
fast.
real time.
I mean, that's one of the benefits of ray tracing.
Yeah.
You know, the benefits of ray tracing is because things are going to behave physically. You should be able to turn things on. If the rest of your system and your models are done properly, you could turn these effects on relatively easily. I mean, it still takes a great deal of great engineering, but comparing to doing it the traditional way of arting everything into existence, the amount of engineering that has to be done is just significantly lower going forward. You know, hopefully, using the laws of physics, when you guys create a scene, things would just look right and behave accordingly. And so this is really just such a great achievement. Wow, things are still falling apart. I've never given a talk in total destruction before. You guys do destruction great. You're great at destruction. That's a lot of pent-up anger there, sir. Lots of great destruction. Okay, you guys made an amazing trailer. Let's take a look at it.
I gotta say, that's pretty impressive.
Looks good.
Yeah.
We're going to talk over a little bit here. Although, hey, I just got my car waxed and I detailed. Oh, no, I parked it wherever this is. Wow, who left that finely detailed and waxed car in the middle of a battlefield? I don't know.
Enigmatastic on Twitch says, didn't anyone tell Jensen $1,200 is a Titan?
Is it? Yeah. Well, I mean, it's
It
what,
was.
600, 800, 1200.
Yeah.
That you are stepping up from the 2080 to that 2080 Ti.
And they got to keep the 10 series around. I mean, you can't.
It feels like
you can't have your
there's gonna
entry-level
be-
card.
Well, people were
Like, they
talking
make
about that in the
coaches for a
chat.
while.
That
Wow,
was
you
a good
guys
point.
killed it.
About like
You
2015,
guys killed it.
how much they're going to cost.
Real-time ray tracing, Battlefield 5. And we have a great surprise for you today.
Oh?
Battlefield 5.
Launching
Open
now.
beta September 6th.
Open beta. Wow. Probably without RTX.
Guys, congratulations on a great achievement.
Yay.
Yeah,
Well,
this
the
is really
cards
a
don't
wonderful achievement.
Launch
Thank
until
you.
the 20th, so.
There are so many other RTX games coming your way.
That's funny.
Developers all over the world are working hard on RTXing.
It's kind of like Fortnite was exclusive on Samsung devices, but the
We're
Note
going to
9
have
didn't
all
come out.
kinds of amazing games coming
That's
your way.
12
after
right
the
there. So
exclusive.
12 titles.
Well, I guess your question
with
is
ray
this.
tracing support.
What are you
Bryce.
going to run it on?
Oh, here we go.
What are you going to run all these
Oh my gosh.
amazing games
Almost
on?
11.
I know, right?
Well, let's show it to you.
Watch
like it is clean looking. You know.
Did it say that it does HK HDR?
8K, yeah.
Ladies and gentlemen.
Oh, here's the money shot. Look, there is a virtual
10
link.
years in the making. The GeForce RTX 20 series. Computer graphics reinvented. Isn't that beautiful?
Nice. There it is.
The craftsmanship is unbelievable. The craftsmanship is unbelievable. This is the best design we have ever done. Everything from the voltage, the power regulation, and the thermal management system, it is designed for overclocking. Crazy amounts of overclocking. Not to mention, it is just so quiet. Even when you're maximum overclocked. At maximum overclock, it sounds like 1/5 the audio levels as a 1080 Ti. It is so quiet. The engineering is just absolutely.
I mean, those reference cards last time were pretty loud and hot and blowing out the back too.
3 models today.
I think.
Someone in chat asked if it's RGB.
We're announcing 3 models today.
I hope.
I don't think they are.
No, they're not.
They have not been.
I just think it's a funny
The
question.
RTX 2070 with 6 gigabytes per second, 5 times that of a Titan X.
Ooh, 5 times. Oh,
5
another
times
bingo.
that of a Titan XP. 45 trillion
Someone get
RTX
8K in
ops
there?
per second.
Does it count if it's on screen?
Yes, it counts.
45 trillion RTX ops per second. That is several times the performance of a Titan X. 8 gigabyte frame buffer. RTX 2080, 8 gigabytes per second, 60 trillion RTX ops, about 6 times the performance of a Titan X for ray tracing, 8 gigabytes, and then the RTX 2080 Ti, 10 gigaраys. I love gigaраys. 10 gigaраys. Shoot as many rays as you like. Go crazy. Just shoot rays. 78 trillion RTX ops, 11 gigabyte frame buffer.
Oh, okay.
Starting at $499.
$499.
Wait, what?
NVIDIA Founders Edition cards are pricier.
$499.
More coming.
Wait, what?
For 1070?
Just listen.
I'm listening.
I just got the release. Yeah.
Pre-orders today.
Prices are lower than what you're seeing us previously say before and what's previously been reported because those are Founders Editions only.
On shelf everywhere.
Oh.
September 20th.
Wait, a 2080 Ti for 500?
No.
No. It's starting. So they announced the 2070. So I'm guessing the 2070 is going to start at $499.
Oh, okay.
And here is your NVIDIA RTX family.
Here we go.
The NVIDIA RTX family. The NVIDIA RTX family.
You waiting for the slide. Come on.
Also,
The NVIDIA RTX family.
You got that slide.
Ladies and gentlemen, I'm going to see the NVIDIA RTX family.
So 500, 700, and
The
1,000.
NVIDIA
Oh, okay.
RTX family.
So they purposely put
Quadro
something on their
8000.
website, I think, to
Quadro
confuse people.
RTX
Well, Founders Editions
8000.
are above.
2 GPUs connected by NVLink, turning it into one large virtual GPUs. 96 gigabyte frame buffer, 166 trillion RTX operations. 166. 166. That is basically 16 Titan X's in one PC. $20,000. $20,000. Now just imagine, that is twice the ray tracing performance of a $68,000 DGX station. Twice the performance of a $68,000 supercomputer. Then you have the GeForce RTX family. The 2080 Ti from $999. The 2080 from $699, and the 2070 from $499, and the 2070 is higher performance than the $1,200 Titan XP.
Although
in what? Yeah. In ray tracing.
But still, $500 for 2070s.
Yeah, it's not
But
horrible.
That's
Look at it
still
this
higher
way.
than
I want you to look at it this way.
1070 and 970s.
Look at this. This is what they look like. The biggest generational leap in the history of computer graphics.
Of course, yeah.
Our beloved Pascal, the best GPU the world had ever seen, next to the Turing family.
Yeah.
It is a shocking contrast. 10 years in the making. So, ladies and gentlemen, the RTX family. So proud of it. Well, that's our show.
Okay.
The GeForce RTX. GeForce RTX, the first to implement the NVIDIA RTX platform, reinventing computer graphics using this hybrid rendering mode of rasterization and ray tracing, compute using CUDA, and artificial intelligence. Artificial intelligence that was trained using supercomputers. And all of those neurons and all of those weights from all of that experience then sits inside your PC, and it generates images that no possible software written by humans could do. And it generates beautiful images. The Turing, the largest generational leap in the history of our company. The most important new GPU we've created in 10 years since CUDA. 78 tera RTX ops. 78 trillion ops. Basically, changing things so dramatically, we have to change the way that we talk about performance. Because in the future, you're going to ray trace parts of the image, you're going to rasterize parts of the image, you're going to use post-processing on some of the image,
1070
you're
was
going to use
400.
artificial intelligence to generate all kinds of pixels that are impossible to generate
970 was
otherwise.
in 300s, wasn't it?
And the GeForce 20, the GeForce RTX 20 series, starting at $499, available everywhere.
And this is Founders
on
Edition
September
Premium too, so I wonder
20th.
if partners.
What do you guys think?
Yeah.
Okay, I have one more surprise for you.
Oh, one more thing.
The guys did something.
Just very Apple.
Yeah, right.
Well,
he's been doing it for a while. He likes surprises.
everything is real time. It's physically based. All the materials are modeled properly.
Cyberpunk 2077.
Reflections just work. Inner reflections just work. The lighting just works. Ambient occlusion just works. Area lights just works. Have I told you that before? Lighting, reflections, shadows, it just works. Everything could be dynamic, no cooking necessary, no art necessary, just turn on the lights. Enormous amount of computer graphics capability then kicks in and draws the rest of it. Everything you see here is all completely in real time. Ladies and gentlemen, have a great Gamescom. It's been a pleasure
what was the one
being
more
with
thing?
you.
I missed it.
This is a historic moment.
Is he gonna do
Computer
one more demo?
graphics has been reinvented. Thank you very much.
What? Did we miss something?
I thought there was going to be a demo. No. All right, so
He literally said one more thing, and
so
then
the demo is real time for people who don't know.
Well, yeah.
I mean, he didn't really say earlier.
True.
And so this demo that you're seeing on the screen right in front of you is actually real-time ray tracing with the brand new 20 series of Turing cards from NVIDIA. I think that was a big deal, right? So like, hey,
yeah,
we
Is
didn't really.
the one more thing
one more
coming
thing,
after
but-
this?
No, that's it. This is real time. So earlier, we sort of assumed because we expect they would not show a pre-rendered video for this demo. He's saying it is real time.
AZ Jower says, anyone looking for a kidney? That's pretty
Be
fun.
careful
So
with
he
that.
didn't go over specs. That's way too granular for Jensen. We'll go over it right now if people want to know.
You know,
Wait, what is this?
Oh, they're just ending with this.
Yeah,
as
so
the
it's
final
over. So
shot?
we could probably just get back to us, I think, Adam.
Oh.
Oh, no.
No,
Is this
man.
the one more thing?
This is like you got to sit through the end of the credits in the Avengers. You gotta like
Yeah.
that. That's cool. So
Oh, no, without ray trace. Oh, no.
So, 90% of people are like, "What's this song?"
Godspeed, Brad.
I've never heard this song before. So, what should we just for people? We're going to sum it up. 2080 Ti, 4,352 CUDA cores, base clock of 1350 with a boost clock of 1635.
That's overclocked.
Yeah.
Yeah.
Base clock so but boost is overclock, right? So
Well, there's a
reference
reference spec that this is still overclocked over the reference specs.
yeah,
boost.
but so that's the weird thing. Is the reference specs, the reference card, the reference clocks are maybe 10% lower. It's interesting that those are lower, but that's just a reference card. I think that sort of assumes you don't put a high-end cooler on it. Everybody that's selling you $1,000 video card is going to put a high-end cooler on it and better.
Right. So I mean, I think you're going to see the reference specs on your
Cheapest
base.
card.
Yeah, your cheap, very.
I don't know who's going to really make a base card though, right?
I mean, you see them from like PNY and some of the like Power Color and some of the smaller vendors.
But not initially. I think. I mean,
I think initially, because you're going to see them from Gigabyte, Asus, and all them, and they're going to have their fancy coolers and all that on them.
Sure. 11 gigs of GDDR6 again. 11 gigs GDDR6, 352-bit bus, 616 gigabits per second of bandwidth. It does support SLI with this new RTX NVLink bridge. And what else? Oh, it does have the new virtual whatever link they're calling for. The power is on the overclock version, slightly overclocked Founders Edition, 260 watts, 250 for reference. Recommended power supply 650, 8-pin plus 8-pin for the 2080 Ti. For the 2080, which is going to be Founders Edition, about 800, but it sounds like the actual sort of like other branded cards could be $700, right? I think $100 less. 8 gigs of GDDR6. I missed the CUDA cores. 2944 CUDA cores. 1800 overclock, boost clock, 1515 base clock. Stock cards are going to be 1710 to 1515. Not exactly a huge difference. 256-bit memory bus. 448 gigs of memory bandwidth on that GDDR6. This one also supports NVLink. It's a 2-slot card. 225 watts of power for the card. Recommended 650 watt power supply again on the Founders Edition. If you go with the sort of lower end ones, it can be down to 215 watts on the card. And it's a 6-pin plus 8-pin. So that's almost like a 1080 Ti as far as power draw. And of course the 2070, which is sort of the every gamer's card at this point, is going to be...
This one's interesting to me.
Yeah. 2,304 CUDA cores, base clock, overclocked version, 1710. That's for the Founders Edition. Reference card, 1620 on the boost clock. The base clock on both of these is 1610. 256-bit memory interface, the same as a 2080. 448 gigabytes of memory bandwidth, and 8 gigs of GDDR6. No SLI support, because you're in the cheap seats, and
it's not that cheap, but
it's still not cheap. Although 175 watts for the card. 100. Now this is weird.
This is weird. I don't know if this is a typo or not, but the Founders Edition is 175 watts for TDP, and the reference specs have it listed as 185.
Right. Yeah, it's a little interesting because on the others, the reference cards are lower spec. on the 2070, the low base card is actually up spec. So.
Well, it's not up spec. I wonder if that
lower, right?
I just wonder if you're getting better power efficiency for the Founders Edition for some reason. It's just very strange, though.
What's interesting too is looking at the 2070, and I think on the 2080. Let me just verify. Although I don't know if maybe they just don't bother to repeat. Oh, yeah, I see. They're just not repeating it. I thought maybe it was implied this could run without any supplemental power. The 2070 is a single 8-pin, 6 plus 8 on the 2080, and then 8 plus 8 on the 2080 Ti. So, yeah, the lowering, the Founders, the reference card is actually lower spec, interestingly, right?
Well, I mean,
lower clocks, lower.
I mean, that's typically what we've seen.
Wait a minute, you're right. So
the Founders Editions always have a little bit of a boost.
Right. But on the 2070, the reference spec is actually higher, interestingly, Now, wait a minute. Why the heck is the...
Why is the TDP higher? I don't know. There's no reason for it because the boost and the
Oh, I see.
the
I
boost
see what
clock
you're
is
saying. Yeah, well, it could be. I don't know.
lower. But I don't know if they just are trying to tout better power efficiency as a feature you get with the Founders Edition.
Oh, and so by the way, the price 2080 Ti starting at $999. Founder Edition version $200 more at $1,200. The 2080 is $699, $700. Founder Edition version is $800, so $100 more. And for the 2070, it's $499, $500, and the Founders Edition is another $100 more for $600.
Man, can we talk about price for a second? Because wow,
It's always about price with gamers. It's always about price.
Wow,
Right?
so I double checked, 970, 330 MSRP.
Okay.
1070 started at 400, and now we're up to 500.
Wait, what was the 970?
970 is 330.
Okay. Yeah, I mean, the 970 was crazy low price, but that's because they didn't turn on all the memory. Sorry, had to throw that one out there.
I know, but still, I'm just surprised how the model numbers are staying the same, but basically because of the performance you're getting is increasing, it's basically changing where you actually fall in the stack. Yeah. So I'm actually wondering if you used to be like a 970 or even a 1070 type, gamer, if now you're going to be going to a 2060.
I don't think so. I think people just sort of suck it up and go to the same. If if you actually put up for 1070, I can see,
but you're
honestly,
going up $100 now.
Yeah, but that's most likely they're going to be fine because the big question, of course, which we'll get into later. I don't want to mess this up, but yeah, I think it's always kind of gone up a little bit. Technology's gotten pricier. Windows 10 has gotten more expensive. People don't realize that it has actually gotten more expensive, except for all you folks who do the alley deals. It has actually gotten more expensive for Windows 10 for OEMs. Hardware's gotten more expensive. CPUs have, except for Ryzen. Otherwise, Intel was creeping all the prices up. Once Ryzen showed up, Intel can't play that game anymore. NVIDIA can't play that game because simply there's enough
competition.
Not enough competition. There is some competition, not enough to make a difference.
Not enough to put pressure on them.
Yeah, I mean, if you were do you want to take the profits to fund making the next best thing? Or do you want to just, I can understand it. I know people don't like it, but when you don't have competition in the market, that's what happens. So that's going to happen. But I think the real big question, of course, people are like, where's my frame rate, right?
Yeah.
It's very much implied, right?
Not a lot of specs.
So, of course, people are automatically going to assume this thing is terrible in frame rates. Otherwise, they didn't talk about it. That's why they're,
Or it's not going to be as impressive when you talk about games that don't have the real-time ray tracing. That it's actually not that big of a jump compared to like current games.
Right.
It's like everything he showed was like, oh, it's so much better than last year or last generation in ray tracing.
If that's the case, though, they wouldn't be able to justify a higher price.
Why?
I mean, if you're not
they
really
charge whatever they want.
I know they can, but I'm just saying you're not really going to convince people to upgrade if you raise the MSRP on what people were expecting and then don't actually give them the performance to match that.
Well, I think that is the disconnect here. I think what people are going is they're saying, oh my God, they're not talking about performance. Obviously, it's no faster than my 1070 or 1080.
I'm sure it is, but
it is probably faster, but it may be only slightly faster. You got to, they get more of the memory bandwidth. There's more CUDA cores. So, I mean, we shouldn't assume that. I know people want to do it. People want to assume the worst out of everything if specs are not released. But it is very likely that anytime we sort of have this big shift, we've done it many, many times before where you're pushing along the one thing that you judge frame rate on, which is frame rate doing this traditional legacy game, effect. You sort of push this new effect. The performance is all about getting faster in this new effect, not about the old stuff. You don't need 400 frames a second in Rise of the Tomb Raider, right? But you would very much like, 80 or 90 frames a second with ray tracing in Shadows of the Tomb Raider. And that is going to be that weird disconnect, I think. And this is not new. This has happened every single time before. There's a new version of DirectX. Developers start to use it. Yeah, it's not really like, for a long time, people are like, these titles are no faster in DirectX 9. Yeah, because it's not about DirectX 9, right? So it's about the next version of DirectX. And that will be difficult, I think, depending on how the card performs.
So we had some questions earlier, and I can't point anyone specific, but they were asking like, how are you going to benchmark these, or Brad, I guess in this case, the real time ray tracing stuff.
And that's going to be the difficult part, right? Because how do you very much people like, 150 frames is better than 100 frames a second. Well, you have a 60 hertz panel, it doesn't really matter. How does a reviewer? It's going to be up to all the reviewers. It's going to be up to Brad to say what's the value of ray tracing today. They did show 12 titles that had ray tracing, and the fact that I got to say it's a good sign.
And real demos for
real demos. We're talking Battlefield 5, which is a AAA title that's going to come out with ray tracing support, and those effects look amazing, and they were real time. So if Battlefield 5 comes in, and it really can, this 2080 can run, and the TI can run that game at what you need, which is frankly no more than 70 frames a second, 80 frames a second, unless you've got high refresh panel. But you get the RTX feature, that's a big win. So as a reviewer, you got to weigh like, well, if you want a card that's going to be able to play all the next generation titles, clearly there is some developer support for RTX and ray tracing. If that is the new future, if that's where everybody's going to go, you do sort of want to. It's that whole future proofing thing, right? You do want to buy that for that feature. But of course, we assume if I had a 1080 Ti, would I sell my card to go run out and buy one of these cards immediately?
I think you would want to wait to see what performance is like.
Right, you don't want to see the performances, and then you also want to see I'd want to know what the performance is in those games like. And we've seen this in the past, not necessarily NVIDIA, but all graphics vendors will say, we support this new effect. Check mark, way. I swear to God.
If he said he kept saying it just works, it's just easy.
We're seeing some more of it now on screen.
Yeah, they're showing a little bit. So I switched to the feed just to.
But here's the example. Here's my perfect example for you. And this is, it's always the dog that I kick. Intel Integrated Graphics.
Why are you kicking dogs?
Because you don't kick cats, because you can kill a cat doing that. Dogs is like, get out of my way, dog. I don't know.
We do
it's
not
in the movies.
condone.
We don't actually.
We not condone.
There's actually a PETA
any
rep right there saying no.
Towards,
what I'm saying is,
animals.
Intel just the other day said, "Hey, look, did they say this?
Did they say this?
I'm just trying if I can say this or not. Is this under embargo?
Well,
it isn't. So they said like, hey, we supported DirectX 12. We were one of the first vendors to support DirectX 12. Yeah, okay, you supported it, but I mean, 12 frames a second is not exactly what I want to play at, right? So that's the thing is so if they support RTX, they support ray tracing at a frame rate that's usable. Because I have seen plenty of these transitions where they go like, oh, we got this new TNL thing. You turn on this feature in the game and you're running at, 20 frames a second. And you're like, oh, man, I bought this card for all this and it just sucked, right? And that kind of kills you because, you bought it because you wanted to be future-proof because the new games are coming. The game doesn't support it at a frame rate you like, then you're going to be angry.
Well, yeah, sorry. Gamerhoid is saying a good point that I was thinking. How do you think this is going to impact VR? He didn't say anything about VR.
I think this it's because nobody cares about VR suddenly. There's people that think VR is dead. It does not. Believe me, AMD and NVIDIA are clearly still doing VR. There's actually that new link on the video card. I saw it in the close-up on the back of the 2080 Ti. It actually has the new USB-C connection.
Oh, nice.
Right, so that basically carries your video, carries data, and your power over that single USB-C connector. Single cable to your VR headset.
I'm really excited.
So,
Awesome. Playing those games, you remember.
I mean, if they weren't supporting it, but clearly they are, I don't know. We'll have to see. I mean, you're not going to go backwards. This is not going to be below the performance of a what? God, you can run it on a 1070 and 970.
But I think the point is, like how much of a generational leap are we talking about in things that aren't ray tracing?
Right.
That's the question I want to see. I think that's the question a lot of other people want to see. And then we got a good question. This is a while ago. Bastinez on Twitch is asking, can you reiterate why you shouldn't pre-order a product like a graphics card before independent benchmarks? Why should people wait to pre-order? Maybe.
Well, you never want to, because generally, if a vendor promises something and then it doesn't turn out to be what it is, you're stuck with this card. You can't bring it back. So you always want to. So he's like, they didn't clearly they didn't talk about frame rates. and I think people see that as a weakness. I don't think it necessarily is. I think, but you got to wait and see, because you want to be able to see. I mean, the judge of whether 2080, 2070 are going to be successful or not are going to be the thing is if you can really play Battlefield 5 with these effects turned on, right?
Right, and it's at a reasonable frame rate.
And it's at a frame rate that doesn't just turn it into like a slow motion.
Molasses.
It doesn't look like it. I mean, for that demo itself, it looked like they were moving pretty good. So, but you do want to wait. You don't, and I've gone through plenty of product launches where we got this new feature. It's in one part of the game, and when you're actually in that part of the game, it's horrible, right? The performance is horrible. It looks beautiful, but it just kills your frame rate so much.
Yeah.
And then it's just like, oh, just wait for the next generation thing. So like some people, if you're really like, if you like the smart move for a lot of people is to wait for the next generation, because then you get video games that support the effect. You get newer hardware that can run it at a higher frame rate.
Yep.
And a newer implementation of it. At the same time, though, if you're playing Battlefield 5 and your friend has a 2080 and you have a 1080, and you're not getting those beautiful reflections, and it just bugs the hell out of you, and then you got to do it. But mostly you wait.
Somebody's mentioned Shadow XPR on Twitch. No HDMI 2.1. Just 1.4A, I think, is what I saw on the.
I think it's HD. What
I thought it was 2.
I thought it was 2.0, 2.B.
I thought I've got 1.4.
Here I've got a 1080 up on my screen right here, and I am seeing. No, they don't say. They don't actually break it out.
I could have swore in the little video teaser thing that they had.
Yeah, they don't break it out exactly. I'm not seeing here. HDCP 2.2. Oh, sorry, here it goes. DisplayPort 1.4, HDMI 2.0B.
Oh,
for the 2080
DisplayPort 1.4. Okay.
Yeah.
I got confused.
Yeah.
Whoops.
And they also have this interesting thing called NVIDIA GPU Boost. It just says 4. I have no idea.
I know. What does that mean?
We don't know what that is.
4.
Brad is obviously in the land of transwarp speed trying to get the information.
Yeah, I'm also hoping to get a Brad sighting in the background, but nothing yet. Also, we got a couple people asking, including John over on YouTube. Did they mention anything about mobile versions? Like
No.
No, nothing.
Not a single thing mentioned on mobile versions. I have a feeling we're going to have to wait. Definitely for mobile versions, they're usually behind a bit. So if this is out in September, I mean, how long was it? Maybe 3? I mean, there's a good chance we'll see these things. We'll see a mobile version at CES.
CES.
NVIDIA, Jensen, they like to wow people, and if they pull a rabbit out of their hat with a mobile 1080, or gosh, it's hard to say.
2080.
Mobile 2080, 2070 at CES. People will be wowed, right? So we'll see. That may be too early.
And what about power? Is there any sort of power requirements on that?
Yeah. So the TDP on the card, or the watts. I mean, the graphics power is 260 on the 2080 Ti Founders Edition. It is 225 on the 2080, and it is
175 for 2070.
Oh yeah, why didn't this click?
Is that a big jump, or I don't know?
I think the 2080 is the same as the 1080.
2080 is the same as like a 1080 Ti, which is an 8+6.
Oh, okay.
So 2070 is more like a old-fashioned 1080 with a single 8-pin, right? And the 2080 Ti is dual 8s, so like a Radeon Vega 64 water cool. Sorry, had to throw that out there. Although it's pretty damn cool.
Put that in there.
All right.
So I don't know. I mean,
well, what do you think of the presentation overall? Before we wrap it up, because it's already lunchtime.
It's already lunchtime.
Jeez,
we got to get out of here. I'm late on writing some other news. What do you think, Lena? You've done plenty of Jensen NVIDIA keynotes too.
I mean, it felt like a standard Jensen NVIDIA keynote where I will say the one thing I do really like about his presentations is how enthusiastic he is about the technology.
Right.
And I feel like here ray tracing is something they've talked about for a while as like their ultimate goal. So it's cool to see them realize it, but I do wonder, like you, just how it's going to play out in actual real time.
Yeah, you
not
gotta-
demo, not controlled environment.
Everybody's skeptical to make sure that they can really hit it, but it is a momentous day in computer graphics, right?
Yeah.
Real-time ray tracing at the consumer level is a big effing deal.
I mean, because you saw the difference between the Quadro cards and
Right.
and then the consumer cards.
Yeah.
Yeah, $20,000.
$20,000 versus $1,200.
What do you think, Adam?
It's a steal. 20,000 versus 700.
There's some classic psychology right there for you. Anchor point.
Yeah, exactly.
Right.
Yeah,
So what do you think, Adam? You impressed? You happy with the news? I mean, it feels like we've been waiting years for it.
Right. I mean, hey, we've been stuck on 10 series for a long time. I'm not super jazzed because I want to see independent reviews.
Sure.
For sure.
Everybody's
I think that's where I care. I mean, the price is not astronomical as what we initially saw on the page.
Right.
So I think that's better for them.
Right.
But yeah, I mean, I still think they're going to keep the 10 series around. I think those are going to sell for a good while. A lot of people are saying, hey, I'm just about to buy a new thing and I'm just going to go
Really?
with the 10 series.
You got $500. Adam just gave you $500. It's just like, hey, for being best video producer at IDG, $500. You're going to go out and you're going to buy a 1080 or a 2070. Free money here. Free money. What do you buy?
Might as well future-proof myself, I guess.
See?
Sure, I'll take it.
Well,
I mean, if it's
but
free.
that's because you said free money.
Yeah.
Free money.
It'd be different if it was his own money.
No, but here's the thing. You have a 1070 in your box at home. Would you go out and buy a 2070 at this point? Sell it for whatever, $300?
He actually has a 1080 now.
Yeah, I have a 1080.
He upgraded.
I did take advantage of that. No, because I mean, who knows what the performance is going to be like for video? I mean, a 1080 is still overkill,
Sure.
even in video production for the most part. So.
Although so the very interesting thing, sorry, I don't want to drag this out too much, but a big deal there was also that the tensor cores in there. So we saw what they can do with all the inference.
True.
So like they were doing real time hair, changing color of hair in the video processor was doing that. Not video, but the tensor cores are doing that. Is that worth it? Because if NVIDIA is working with Adobe and they add that as a feature into Premiere where you can real time change somebody's hair, and it basically is going in, is looking at your hair, picking out what on mine head that won't work, but on your beautiful hair and Elena's hair would work. Right? Is that worth it?
Oh, they're showing another demo, so I'm just going to switch over. No, that's not worth it. Also, we have a breaking question from John. He's saying, I already ordered a laptop with a 1070, the Helios 500 for $2,000. It's his last chance to cancel his order today. Should he?
I mean, how long can you hold out? 'Cause
Yeah,
it's
you
one of
don't
those
know.
things where it's like you can always wait for the next thing, but what will you lose in that time that you wait?
I mean, they're not going to do anything with Max-Q for this new line. I mean, before CES, right?
there's
yeah, so you have a good 4.5 month plus wait.
Yeah,
and that's
ahead of
I mean,
you.
that's assuming it is going to be at CES.
You're right. Nobody really knows.
However, if you wait even just a couple months, you might be able to get that same laptop for cheaper. So
true. Yeah.
Right. But if it's
I'd
a
say
different,
just do it.
I would say just do
Yeah,
it. And then the thing is,
a
if you have it
1070 in
now,
there still.
and the part comes out in say 6 months, you have 6 months of enjoyment of games.
Yeah.
If you have nothing, then what
you have
You're
nothing.
gonna just sit around and do nothing for 6 months.
You can read a book.
Yeah, you can do that. So, I mean, the graphics realism in books cannot be touched yet. The human mind, you can't touch the graphics realism of the human mind.
True.
So-
Or lack thereof.
All right. Well, I think why
Lunchtime.
don't we wrap it up because it is late. We've been doing this all morning.
Yes.
Not getting other work done. Thank you guys for coming and
hanging out.
and hanging out. I think we're gonna have a full nerd this week. We're gonna try to get Brad on the horn from
That'd be
Germany.
awesome.
Figure this out. If not, maybe he can regurgitate some stuff and we just read a Brad press release.
Someone will hold up a little picture of him.
Yeah, exactly. So, don't worry. We will do a Full Nerd. So subscribe to Full Nerd on your podcast feed. We stream it live on YouTube and Twitch. So chime in for that. But yeah, until then, I guess you guys will pour over all the details, right?
Mm-hmm.
See how it's going.
Commit it to memory.
Right.
Absorb it into our very bloodstream.
That's a big day. Finally, we're done, right? Just kind of like,
Yeah, it's here.
Oh,
it's here at least.
How many people got bingo? We should probably ask.
I think several people.
I got 2
I got
bingo.
0 because I wasn't here for a
I
part
wasn't
of
listening
it.
to it close enough.
I know one person in the chat at least screamed out when they got bingo. So.
Cool.
Yeah.
And yes, subscribe to the Full Nerd because it's our awesome podcast where we talk about PC hardware.
Yeah.
And it's an audio and video form. So, and then subscribe to YouTube. Hit that little button, or on Twitch if you don't already. So, thank you guys, and we will see you later. Yeah. Thanks for getting up early,
Thanks
Gordon.
for coming. It was tough to get here early, but it was fun.
We did it.
It was worth it. It was worth it. Oh my God! Now I just can't wait for a new graphics card from
Vega 2
from
AMD.
AMD, right? That'll be.
We're hoping.
Yeah, we'll see. All right.
All right.
Thank you guys. Talk to you later.
Later.
Bye, everyone.